Yeah, Baxley, that's a good idea. We still have 5 years to prepare, comrade. Yeah. Alright. We'll move over to space news. And go from there. I enjoyed Hearts. That's yeah. We'll keep going with that offensive. Yeah. For some early hours. I think we'll swap between like Hearts and Satisfactory for the early hours. That should be fun. Okay. I'm going to take a second here. I'm going to go refill my coffee. I'm going to grab a quick bite to eat. And then we will... I've played Hearts before, Solaire. It's fun. It's a fun time. Anyway, get those space news links ready, guys, and we'll go from there. Free space news entertainment of Satisfactory. What is this? Hey, Chaos. Bossy, you got links? Okay. Cool. Pretty chill stuff. All right. What is this? We'll start with this, but I'm gonna take 5 real quick.
At Fixit Incorporated, we have a vision. A vision to save the day. To be the future. To make history. In style.
How are you? That's pretty cool. Man, I saw this and I just got a bunch of new ideas for building aesthetics and stuff. Look at that. Can we get screens like that? I don't know. I love how they put the signs in. That's funny as hell. Yeah, I wish the doors did that. Tell me you saw the last few seconds with the doggo. Maybe. Man, how are they making those roads? Concrete texture with the decals, huh? It's got to be that. Is this game made in Unreal? Asphalt foundations? Wait, is that new? We only had concrete. Oh, now I want to play this. Damn it! Why, chat? Now I want to make roads. Oh, now I God, stop it. Oh, I made a sweet train route yesterday, too. Ugh. I like that sign. That's actually really cool. I guess we're playing Satisfactory. Nobody will judge you. Damn it. Why are you doing this, chat? Why are you doing this? Oh, the indoor train station. The freaking indoor train station. Ugh. I'm taking a break. I'll think about it, okay? I'm surprised you don't have an indoor train station. I didn't even think about it. Should make that train station needs to be indoors. All my train stations need to be indoors. You must automate for the good of all humanity. Now I want to redo my roads. Damn it. I want to redo the roads all the roads that we made to make them. Oh, you guys suck. You really suck. All right. I'll be back. We'll think about what we want to do after Space News, okay? Damn it.
Meet Mr. Archimedes of ancient Greece. Long ago, Archie said,
"Give me a lever long enough and I can move the world."
What Archimedes meant was that the power of a lever is practically unlimited. Today, almost everyone uses some form of lever in his daily work. The familiar can opener is a lever with a sharp cutting edge. The playground seesaw is just a simple lever, too. It takes a lot of force to start a freight car moving, yet the railroad man can start the heaviest freight cars easily with a pinch bar, a powerful lever which turns the wheel. Tough luck, old boy. Here's a place where a lever comes in mighty handy. Let's take the simplest kind of lever, a rigid bar working on a fixed support called a fulcrum. One end of this lever is twice as long as the other. Let's put a 10-pound weight on this end, and now we'll put half as much weight on this end. 5 pounds, balance 10. If we have 25 pounds to lift, we just use a longer lever. The 5 pounds will now balance 5 times as much. Let's raise the lever in the air, change its shape a little, and we have a crank. Or we can add a second lever and have a double crank. Now the short arm moves 1/4 the distance, but we get 4 times the force. If we want continuous motion, we need more arms. Now we have levers that turn. The larger paddle wheel makes fewer turns, but it delivers more force. A paddle wheel is nothing but a never-ending series of levers. We can make the wheel stronger and lessen friction where the wheels touch each other by rounding off the edges and shaping them into teeth that will slide in and out smoothly. Now, the power flows smoothly and continuously through spinning leverage of gear wheels. Gears are made in many kinds and many sizes. Little gears, big gears, worm gears, bevel gears, and even lopsided gears. Over 100 million gears are spinning over the roads in the transmissions of our automobiles. The transmission is located right at the bottom of the gear shift lever. Let's start from scratch and put together a model of the gears that we shift in our motor car. The shaft on the left comes from the engine. The shaft on the right carries the power back to the rear wheels. To connect these two with gears, we'll need another shaft, known as a counter shaft. These two gears carry the power from the engine shaft to the counter shaft and are always connected or in mesh. This gear on the drive shaft going to the wheels is free to turn around the shaft. We'll put it in mesh with another gear on the counter shaft. These gears are always in mesh and keep turning while the engine is running. To switch from one set of gears to another, our transmission needs a short shaft like this, known as a clutch sleeve. It cannot turn on the drive shaft, but it is free to slide back and forth. On the sleeve, we'll mount a large gear, which we can shift back and forth to mesh with the small gear in the middle of the counter shaft. We are now in neutral. The gears that are always in mesh are turning over with the engine, but the shaft to the rear wheels is standing still. A 3,000-pound automobile takes a lot of force to start. So in low speed, we get the greatest leverage by letting the smallest gear on the counter shaft turn the largest gear on the drive shaft. The engine on this model is running at a constant speed of 90 revolutions a minute. With low gears in mesh, the rear wheel is turning at 30 revolutions a minute, about a third the speed of the engine, but with 3 times the force. The power is going through these gears in the transmission. After we've started the car rolling, we want fast pickup. So we shift into second by sliding the sleeve backward to mesh with this gear on the shaft to the rear wheels. The wheel is now turning at 60 revolutions a minute, and the power flows through these gears. For higher speeds, we let the power go directly to the rear wheels. We shift the sleeve forward so that it meshes with the shaft from the engine. The power travels straight from the engine to the drive shaft. Now the shaft to the wheels is turning at 90 revolutions a minute, the same speed as the engine. But here's a problem. An automobile must be able to go backward as well as forward. So we add one more set of gears to reverse the shaft to the rear wheels. With the gears shifted into reverse, the power travels through the transmission in a path like this. We now have 3 sets of spinning levers for going forward and 1 for reverse. With a gear shift lever, we can shift to any set of gears we wish. But with all these spinning levers in the transmission came noise and wear. Experts could shift gears quietly by careful timing of the gear shift and the engine speeds, but most of us made plenty of noise until new engineering developments made possible the long series of improvements that followed. When we shifted gears, we got a clash because the gears were not running at the same speed. In other words, not synchronized. So engineers set to work to develop a synchronizer. The synchronizer works like a cork twisted into the top of a bottle. The cork will turn until it is so tight that the bottle turns with it. Synchro mesh works the same way. When we shift into second or high, the synchronizer brings the gears to the same speed before they come together. The drums won't let the gears shift unless they are turning at the same speed. When the gears come together, there is no clash, and the shift is made quietly and easily. In the transmission of the up-to-date automobile, we have a powerful low gear to give us a strong spinning leverage in starting. A fast-turning motor must set the weight of the car in motion. In second speed, we can change leverage to get going fast at the same engine speed. With the leverage of third gear, power goes directly to the rear wheels, and we can go as fast as we want. Now, every driver can shift gears at any time, regardless of speed. Here is a hill that will give us a real chance to see how smoothly and reliably our spinning levers work in our automobile transmission. This driver is going to let her car gain a speed of 60 miles an hour down the hill. Then she will shift into second speed and bring her car easily and safely under control before it reaches the bottom of the hill.
The rear axle in the old wooden ox cart had only one job to do. In this type of vehicle, the power was supplied from an outside force. The cart was either pulled or pushed, while the axle was stationary and had nothing to do but support the load. With the coming of the automobile, it became necessary to transmit the power of the engine to the rear wheels. So room was made for a shaft to transmit this power. Next, room had to be made so that the differential, ring gears, and pinions could be inserted. Of course, when this was done, a strong connection had to be made to join the two tubes together. Chevrolet engineers built a strong cantilever bridge across the cut in the axle, making it even stronger than the old solid axle. The three units of the rear axle housing, the bridge, and the two tubes are firmly assembled into one complete, sturdy unit. Chevrolet engineers realized that this part of the axle should be easily accessible from the outside, so an inspection plate was placed over the rear of this banjo construction. The rear axle now became merely an axle housing to support the load. Next, gears were added to transmit the engine power to the axle shafts and wheels. All these axle shafts have to do is turn the wheels. They do not bear the weight of the load, as it is borne by this husky axle housing. One of the outstanding features of Chevrolet's new full floating rear axle is the barrel-shaped roller bearings, which are entirely self-aligning. Because of the barrel shape of these rollers, they form only a small area of contact with the races under normal load conditions, reducing friction to a minimum and keeping the rollers in exact alignment. As the load is increased, each roller spreads into the bearing race, providing support along the width of the bearing. When the load is decreased, again the area of contact is decreased, so that the capacity of the bearing is always in proportion to the load.
Wheel bearings are still
This
made that way
feature
for what it's worth.
prevents the races from becoming grooved, as is common in straight roller bearings, and the bearing life is therefore greatly increased. In order to show you the action of these bearings, this drawing has been greatly exaggerated. Another important advantage of Chevrolet's full floating rear axle is the 4-pinion differential mounting. This means that any load is spread over 4 teeth instead of only 2, and ensures less strain on all parts and longer axle life. In addition, the rear axle housing on the 1936 Chevrolet truck is 35% stronger than last year's housing. In fact, this housing alone is stronger than the combined strength of the housing and shaft in previous models. This new, heavier, and huskier rear axle housing with inspection plate, together with the new exclusive self-aligning bearings, combine to make this full floating rear axle the finest axle ever built into a truck. With this construction, axle shaft breakage is extremely remote. But should it ever happen, the Chevrolet full floating rear axle permits easy removal and replacement of either axle shafts without taking off the wheel or removing the load.
Man, that looks awfully familiar.
The design of the axle with the smaller banjo center gives it much greater road clearance,
I took apart one
which
of those
is another
recently.
advantage that helps to make this new axle the outstanding development in the 1936 Chevrolet truck.
Yeah, hub-centric. Or not non-hub-centric because of the axle. Yeah, it took apart a rear end that looked exactly like that. Turns out the design doesn't change very much. Yeah. Seriously, the design really didn't change. So this is a full floating rear axle, meaning that, so the axle transmits power to a hub, and the hub is what holds the wheel on. And the hub is on a retainer plate that's inside of the drum, right? So you can take the axle out without taking a wheel off. Yeah. Now, here, take a look. Now, here, take a look at this picture. Seriously, look at the rear axles on the truck. Specifically the one that voided itself. Uh-oh. Non-hub-centric, full floating rear axle. That's what that Sterling 1025 is. The tech hasn't changed much. It's only so many ways you can do something. But see, same thing. From a truck that's 90 years newer. Why did you leave the door open again? Oh. There. Because I forgot to close it. It's not a hubcap cover. The axle. That's the outside of the axle right there. We took it apart. 60 years newer. 90 years now. 60. Yeah, because it's a 90s truck. Yep. So 60 years newer. Same design. Stuff hasn't changed very much because there's only so many good ways to do things. See that? Now explain NASCAR's axles. No, I'm good. Yeah, when they work, it works. There's a reason why Ford didn't change the design much for a very, nor Chevy. Neither of them changed the design very much. So check this out. The other end of the axle is right there. See that little hub in there? Not little hub, that little cylinder. I know the spider gears are destroyed. I get it. See that right there? That's the other end of the axle. The axle is on splines. So the axle has basically a gear on the end. And then this spider gear has the reverse of the axle on that. And the spider gear drives the axle. And the axle has those same tapered wheel bearings. That hasn't changed either. Most cars have tapered wheel bearings like that. In fact, like a lot of them do. Yep. There we go. And then the other axle is connected to that spider gear, which is also destroyed. But they work. Still got that rear end in the truck. Still drives. I mean, those gears are hardened steel. They ain't going nowhere. And yeah, for someone that said it, the ring doesn't use a worm gear. It's a pinion gear. Differences. Worm gear and pinion gears are a little bit different. Namely, it's how much the gear teeth curve. But you with a pinion gear like that, you can basically drive from anywhere. You could drive from down here if you really wanted to. You could drive anywhere on this side of the axle. This one is a straight drive, so the pinion gear is like right behind the drive shaft carrier. You're not looking forward to replacing the rear axles on the Commodore. Yeah, it's Chaos. Yours are way easier than that, believe it or not. But you got to take the rear brakes off. But so on the Commodore, you should have an axle flange, right, with the spokes in it, right, and then there should be another hole. So, like, there should be a hole that's drilled right through the axle flange, and then there's a retainer that holds the axle in. You use that hole, move the axle around, undrill it, and just take it out. It takes 2 seconds. Yeah, it's not really too complicated. Like I said, they really haven't changed. They haven't changed much. That's the outside of the axle right there. And then the hub is attached to the tire, which is being held in by the brake. Well, not really held in by the brake. I mean, it's kind of... The axle retains the hub on there, but you can change the axle without taking the tire off, which is cool. With that axle that Chaos has with the retainer plate, you'd have to take the whole tire off. But I can just undo 1, 2, 3, 4, 5, 6, 7, 8, and I can pull the axle right out. But anyway, let's take a look. So that's called a full floating rear axle. Trucks have those for maintenance purposes and strength. Strength and maintenance and strengthenance words. Anyway. All right, let's I'm loading up all the space news stuff here. Are you an engineer or something? Sorry for the question. I don't mind asking questions. No, I'm not an engineer. I'm self-taught. Self-taught, buddy. I play one on Twitch. Yep. No, I'm not an engineer. I taught myself all this stuff, especially with rockets. It's all self-taught. Bimbo, I like this stuff. Nice name. I like this stuff. The mechanics are like candy for your brain. You should be. Yeah, I appreciate that, man. Thank you. Let's see. So, let's load up the... Let's load up Starship stuff. There's some cool stuff that was done over the weekend with Starship. We're gonna... You know what? Let's start with that. Why not? Alright. Got any vids on how a spool differential works? Spool diffs might as well be black magic. It's one of those helicopter things. But here, we'll start off with some Starship videos here. Here, let's check it out. So this is coming from NASA Spaceflight here. Figure we'd start with this. Or not. Alright. So, we'll start off with Starship, and then we'll get to a bunch of other things. We do have a rocket launch late tonight. It's technically tomorrow morning if you're on the East Coast at 1:20 a.m. We're going all the way to it. The launch tonight is NASA's DART mission. Here, let's pause this for a second while I'm here. NASA's Double Asteroid Redirect mission. Basically, what they're going to do is they're going to launch a satellite on a Falcon 9, and that satellite is going to impact an asteroid. And then astronomers will monitor whether the course of that asteroid had been changed from the impact. Basically, trying to redirect an asteroid's trajectory. This is a mission that's launching tonight. It is a really cool mission. You're definitely going to want to stay up for this one. We got a very high-profile Falcon 9 launch. Is it a big asteroid? It's big enough. When will the impact happen? It's going to take a little bit to get out there. I'll give you guys a full brief on the mission profile when we get closer to the launch. But yeah, it's actually a really awesome mission. The funny thing about being French is that I can follow space news now, go to sleep later, and wake up and watch DART launch here with a cup of coffee. Yeah, there you go. Is there any kaboom? They're litho-braking an asteroid, Deepic. They're just crashing the satellite right into it. I think the differential velocity is like 16,000 miles an hour. Pretty awesome. So in how many hours will it take for to wake up for the EU? It's going to be early in the morning, guys. Early in the morning for you. If you're CEST, what is it? 7 in the morning. 7:20 in the morning for you guys. Mission seems simple, but it's going to be monumental. I agree. Yeah, 7 a.m. All right, let's get back to the Starship video. Let's see what's going on down in Boca Chica. Yeah, I'm going to have to do a lot of explaining with this one, but yeah. All right, so let's keep going with Starship stuff from NASA. Yeah, I can show more about that later. So Jeb is on this mission since they are crashing DART. That was a good joke. Hopefully you can pick up on the sarcasm. EJ's paranoia is going up. We have suspected capitalist joke makers in chat purged. Purged! And we never heard from Brim Navans again. Off to chat gulag with you! One thing that I don't understand, why are they loading N2 again when they spent the last week loading locks for the launch pad? More testing. And no, gaseous nitrogen is in there for other reasons, Alex. I think they used that to inert Starship, if I'm remembering correctly, but someone's going to have to chime in on that. Yay! Wait, what are my values? Hey, beautiful. Cryoproofing, you mean? I guess it's needed. No, they have GN2 tanks on the tank farm, Alex. It's used for something. My guess is they use it to inert and purge out the tanks before they fuel. That's my guess. But I forget the exact reason. Furd. Two Furds. Furd cement mixer and Furd truck. Deal with it. Hello, baby. Those are missing tiles, Jay. Yeah, they'll replace them soon. Would you look at that? Ford's getting work done yet again. I know, Smirks. Funny story. Actually, it's a funny story behind that. You're gonna love this. True story. Ooh. While we're on the subject, I wanna show you guys something. It's not necessarily space news, but it is funny. I think you guys would appreciate it.
Discovery, go at throttle up.
Let me find it. Ah, yes, here we go. Hey, Rhino. 7137. Howdy, peeps. Finally got your Bronco. Nice, man. That's cool. Is it a Bronco Sport or a real one? Or the big one, I should say. Chevy Bolt production halted through the end of 2021. Oh, they're transforming America. Oh, yes. Keep up the crap posting about Chevy. I love it. Yes. Oh, that's great. That makes me so happy. Oh, you hate to see it. I'm going to write an angry Yelp review, Smirks. I'm going to start the Karen haircut. Playing devil's advocate here, but for a while, the Bolt did have the highest voltage battery on the market. Bolts aren't bad, Alex. They really aren't. They catch on fire, though, so in that regard, they're pretty bad. Yep. I don't think you hate to see it. No, it's great. The only one of the big three that Elon actually respects and talks good about is Ford. It's true. You ever see him badmouth Ford? Nope. He never does, because he likes Ford. He's a Ford guy. Seriously. It's true. True story. Okay, he's not a Ford guy, but also at the same time, he doesn't talk bad about Ford. No way. No way. No freaking way. No way. No. No, there's no way. No. No, that can't be a thing. It's fake. Damn. But also at the same time, fellas, unusual activity alert on JP Morgan's page. Nice, Neon. This business recently received increased public attention, which often means people come on this page to post their views on the news. When we don't take a stand one way or the other when it comes to this, we temporarily disabled the posting of content on this page. Oh, okay. Okay. Yep. All right. All right. Let's go back to the Starship. Back to Starship stuff. Okay. Okay.
Discovery, go and throttle up.
Raven Guard, 20-month resub. Thanks, buddy. Poop storm activated. Space news, fresh off the press from the Daily Hopper. You feel that? No. Better scrub just to be sure. Dude, that thing is... Oh, I see what they're doing. Check this out. Look, so see the pulleys right there? Look at this. So you got the pulleys right there, but there's one wheel with one cable that goes back down. Who knows why? What happened with JP Morgan? I think they're like trying to sue SpaceX or something. Forget. Nope, it's not leveling, guys. It's just how a pulley works. So you have one pulley that's pulling that's connected to here, right? And it spools around there, and then you have the wire. All right, so here I'll show you. Look, check this out. So you have one wire, right, going in, and then you have a circle here and a circle here, right? And those are on cylinders like this. One of them is on the chopsticks. The other one is up at the top, right? This is on the chopsticks on the carrier plate, so chopsticks, and this is on the orbital launch tower. You have one cable that goes in, and the cable goes around, and then it goes down here, and it goes around, and then it goes up here and goes around, and then it goes down here and goes around, then it goes up here and goes around, then it goes down here and goes around, etc., etc. The idea here is that you have more cable doing more pulling. It's pulley. Basic pulley. See that? All you need is one cable. Cranes do that all the time. It's just, it goes back and forth a bunch of times. Like, it spools back and forth. So all you got to do is pull on one cable, and then instead of one cable going down, you have a bunch of cables, so you can spread the load over all those cables, and then one cable does all the work. One cable is... It's just one cable. It's just spooled around, and then you can pull those things together a lot easier. It's just basic pulleys. Very basic tools, but yeah, there it is. See it right there? One cable. All you need is one cable, and then it spools around a bunch of times. Oh, a lot, Hellfish. Yep. Snatch block. Pretty cool. See? That's all one cable. It just goes down and up and down and up and down and up and down and up. Yeah, you can do cool things with pulleys. I mean, that's one of the six basic tools. Good stuff. Biggie. Sorry. I got 7 SN7s, about 8 SN8s, 2 SN9s, 1 SN10. Stuff's never end. You can't touch my riches, even if you had Jeff Bezos and the Blue Origin. Sorry. Can't you see? Yeah, there you go. Elon Musk, the billionaire, the Starship, the launch, 2 launch pads, 2 hot rockets. Bruh, I don't know. I'm sure we could come up with some rhymes that fit. But yeah, and then we got to put it to Thomas the Tank Engine. Then we gotta link it to Elon and be like, yeah, please don't rap. It's hard to write rhymes about space stuff. All right, what are you gonna rhyme Starship with? What are you gonna rhyme Starship with? You can't rhyme Starship with Marsness? Fart shift. Yeah. Michael Strahan's going to space. Any idea why you do it? Nah, I don't know. Hardship. Yeah, there you go. There you go. There you go. What's up, Wacky? How you doing? Starship that can crack the whip. Elon raps would be nothing but flexing. It'd be pretty good. That's why Hypnotize is funny as hell. That'd be awesome.
Discovery, go at throttle up.
I mean, Snickers, probably that one. Large drip. Cool whip. Yep. We're going to launch the Starship, and then Stewie will show up with some cool whip. Nope. 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 Nope, not good. Cool whip. We had an interesting discussion about nuclear energy at Horizon Side. Cool. Guilt trip. That's good. That's good. Pudding. Pudding. Let me tell you that NASA was voted the best place to work of any federal agency, and it's because the proof is in the pudding. And when I say that, I mean that we actually have really good pudding. Our pudding was voted the best because of Apollo 8. You remember Apollo 8? Pudding Nelson out of here. Rockets? Wait, no. Just pudding. Do you think we could lower its temperature by releasing a lot of liquid nitrogen since it's extremely cold? The problem is, Liam, I mean, you might have some effect with that, dude. The thing is that there's this thing that rises every morning that heats everything up. Yeah. Yeah. The proof is in the pudding, Mac. I'll tell you, Mac, does the cafeteria serve good pudding? That's very important to me. This is hilarious. Also a long link. I'll have to check it, Bandit. They have good pudding. Well, that's what I thought. All right. I don't believe you. I live in Western Norway. I haven't seen that plasma ball in months. Well, I tell you, you haven't seen the plasma ball, but have you seen bowls of pudding? Well, I'm gonna make pudding tonight. Yeah, I know, me too. This is SN21 here. That looks more spaceshipy than the other one. Than SN20. I'm not gonna lie to you. The tiles are getting very uniform. They're getting very good at putting these tiles on. I mean, look at, so it's really easy to see where the glare is, right? You can, because the tiles are getting lit up. There's not a lot of abnormalities in the tile structure here. There's a couple of thick edges like right there, but once again, the more they do this is what, the second attempt at full tiles on a Starship. SN21 has some broken parts here and there. There's some gaps going on, right? But this thing, look at how uniform those tiles are. They're very uniform. Dumb question. Are you doing FDR or JFK? No, I'm doing Bill Nelson. Bill, proof is in the pudding. Nelson, the NASA administrator. If I was doing JFK, it would sound like this. It would sound completely different because that's an accent from my neck of the woods. It's also Gwen Shotwell's birthday. Well, happy birthday to her. She is a very young and healthy 29 years old. Anyone going to correct me on that? Yeah, that's what I thought. She's 29, all right? All right. Yep, you're not going to correct me on that. Yep, 29. She's 29, bros. Younger than me, I know. It's strange. No, she's 27. Get it right. I mean, maybe. Nope, I've already been timed out today. That sounds like dissenting thought. You're suggesting there's some kind of conspiracy to time you out, Bram? Guess what, Purged? You've been memory holed. I just got plus 27 PP for that. Okay. Of course he is, Bandit. Save the timeouts for serious potato bot. Still jolly strong. Da. Perched. A student says they have to go to the bathroom. Dissenting opinion. Kill them. And have spectator number 1 killed. Sorry, it's just playing that game, man. Sorry, you really like to get into the mindset. Kill him. You know, I've noticed this, but I've never really wondered why. I wonder why this has such a different tint to it. Tell you what, I want to speak to your manager. You can't speak to the manager, Bram. I shot him in the face. Manager? There's no manager. Purged. Not polished? That seems to be the case, Vasya. Yeah, I think so. Is that a Tor? If somebody asks to see their manager, you tell them you are the manager. If they have Mac, tell them we use PC. And if they have PC, tell them we use Mac. And if they have both, well, tell them we use Linux. And if they have that too, tell them the whole system went down. Why? Because screw them, that's why. Good reference, friendship. Welcome to Popular Copy. Yeah, I don't care. I'll go to Rikers for 20 years to prove my point. I don't give a frick. What do you want? I want to see your manager. Yo, what's up, man? I am the manager. You're the manager. I'm the manager. You're done, son. You're done. It's Popular Copy. Pop Copy. Yes. Good afternoon. Hell yeah. Mess with toes. Good afternoon. Welcome to Pop Copy. Can I help you? Great chef. Yes. Good afternoon. Welcome to Pop Copy. Can I help you? All right. Anyway. So that's Booster 5 being stacked in the high bay right there. Okay, so note that the pipes on this thing aren't connected. See these exterior pipes? they're in kind of 4x symmetry around the booster. Those pipes are the methane autogenous repressurization lines. So what does that mean? I love how we can just pivot. But anyway, this booster it's not finished being put together. They did mate it the other day, meaning they put the methane tank on top of the oxidizer tank, but the AP lines aren't hooked up yet. To simplify Starship and Super Heavy's design, they use something called autogenous pressurization. So what is autogenous pressurization? Basically, where they tap off the methane, hot gas. They tap off the methane, gaseous methane
Discovery,
from the turbo pump before the pre-burner, and they send it back up into the tank to keep the tank pressurized. Because rockets have to maintain a steady pressure inside of the liquid fuel and oxidizer tanks. Usually, I mean, they have to maintain what's called tank ullage, right? So you have to keep the pressure from shifting too much while the rocket's going up. Now, how do you do that? I mean, the rocket's draining fuel, so the pressure in the tank would theoretically go down, right? So what they do is they put gases inside of the tank. Usually on like Falcon 9, for instance, it's helium. They pump helium into the tanks while the fuel is draining out to maintain tank pressure. Why helium? Because it's helium. It's super light. No. Amongst other reasons. Now, Starship, if a Starship or a Super Heavy, I don't know about Super Heavy, but if a Starship's ever going to go to Mars or something, right, you're not going to have helium there. So you got to find other ways to do this. So they simplified the design by having a gas tap-off from the Raptor engines. The gas tap-off is called autogenous pressurization. So they tap methane off of the turbo pump, and gaseous methane goes up this pipe into the methane tank. And once again, it goes down to a manifold here that's coming from the engine. So gas is actually flowing up this into the methane tank. Now over here, you can just barely see it, but there's the LOX one that's kind of next to it too. It's over there somewhere. And that one would go into the top of the LOX tank. So that pipe would end right here. But that one is not completed yet, indicating that Booster 5 still has some ways to go before it's finished. Yeah, helium's inert, and yeah, I mean, there's a bunch of reasons why they use it. Hey, Space Herb, 27 months, and Human Person is a 29-monther in there. Thanks, guys. And Mac had a 7-month in there. And then Horizon Sai had a raid in there on top of that. So that nuclear discussion, what were you guys talking about, believe it or not? Sorry, I had to go on that little spiel there. Also, popular copy. Steady Pressure is a good name for a college alternative rock band. Agreed. We discussed the differences between energy released in fusion versus fission. Oh, okay, Flask. That's some real nerd stuff right there. Sure. So, I'm actually not too well versed with fusion. I know that the energy released from splitting the atom is neutron flux. So neutrons get popped out and they hit another thing and they split that one, and then more neutrons pop out. With fusion, though, what's the byproduct? Well, the byproduct, I guess, would be ions. Refresh my memory. And I know that the neutron flux is what creates that energy. It creates heat. That's the chain reaction part. Fission generates a lot of heat in the process. Well, yeah. Photons as well. Fusion is a very bright process. Yeah. That sun that comes up. Don't stare into that. Yeah. Exothermic reaction, basically. Yeah, there you go. Forgive me if I'm a little scatterbrained today, fellas. Because of course I did. I had a nasty case of insomnia last night. I stayed up till 7:30 in the morning. Not by choice. Not by choice. Yeah, so I'm running off 8, 9, 10, 11, 12. Yeah, a little under 5 hours of sleep. Yeah, great, good. But don't worry, we'll reel it back in. Of course, Alex. Yep. I mean, I think you can get... I think you get more heat from... You get more heat from fusion. Isn't fusion a more energetic reaction because, you know, sun? Yeah, Laserman, it happens. It happens. No, not yet, Xenon, but we'll get to that. That happened to me on Sunday night. I got like 1 hour's sleep. Oh yeah, you take ads for your ADD, so no naps for you. Oof. Yeah, that doesn't happen to me, Mac. So, like, I tried to go to bed after the stream last night. I was like, okay, it's midnight. I'll go to sleep. I went to bed, and I slept for about 30 minutes. Had a nightmare. It was actually a pretty cool nightmare. I had a nightmare that I was in Dune, which was pretty neat. I mean, like, I can't be upset about that. That was pretty cool. The worms, though. Yeah. I slept for about 15 minutes, and then I went, and then promptly stayed up until 7. Yeah, that's good. Played a lot of chess last night to try and tire myself out. That didn't really work. Had a nasty headache. You know. These are normal people things, right? This happens. I cured my insomnia by drinking so much coffee for years that you're immune to it. Interesting. Yeah. How'd you do in chess? Not very well. I beat a 600 on the first try. And then I went up to 1,000 and got my tail handed to me probably like 13 or 14 times in a row. So I was 1 in 13. Yeah, very bad. Your boy is not good at chess. But see, the thing about chess is that it's like mission mode. You really have to focus. You really have to keep track of a lot of things. It's like playing an RTS. It's like playing StarCraft. Same vibe, same energy right there. Have you beat Sven yet? I have not beaten Sven yet. No. That guy is ruthless, man. Yeah, Ice Mage. Yeah. Yeah. Blue light. That doesn't have an effect on me. Like I can be on the computer and then fall asleep to it. You know. Interesting, Chris. Interesting. Yeah, Bandit, it's a lot of... I mean, chess is brain food, dude. It really is. There's a lot to think about. It's like a space program. There's a lot to think about, and you really have to cover your tail. Really. And trying to set up an offensive is extremely difficult. Because your offensive is trying to predict what the other guy is doing. But if the other guy realizes that you're trying to predict what he's doing, he's going to do the opposite of that, and your offensive is going to be screwed, and then you lose. It's a really, really hard game. I like it. I really like it a lot. Dude, interesting piece of info. Interesting, Mac. Yeah. How long will it take Dart to hit that asteroid? It's going to take a little bit to get out there, Wookie. I don't have the exact mission timeline. I don't know off the top of my head. Once again, your boy's a little today, but we'll get it. Anyway. Also, can we hurdle a dart at an asteroid in mission mode now? Maybe. I'll think about it. Well, I need to get Sentinel up, and I need to start tracking asteroids. But in order to get Sentinel up correctly, I need a deep space network. So we got to start working on that. Do you have a favorite opening yet? I like E4. E4 if you're playing white side. So I like Sicilian. Sicilian's pretty straightforward stuff. So E4 and then knight to C3, something like that. So that was the first one. There's 3 more of these videos. Check this one out. Once again, this footage is coming from our buddies over at NASA Spaceflight. Go over there and give them a YouTube channel to sub. See if you support them in any way we can, guys, because they give me basically unrestricted access to these videos, dudes. That's not something that they do for everybody. So make sure we hold up our end of the bargain and go over there and subscribe to them. Seriously, boost those numbers. We're not seeing enough numbers. We gotta pump up those numbers. Of course, you like Sicilian. You're Italian. It's a really easy defense. From what I understand, tracking it from the ground won't be enough, as the position of Didymos is known with a precision of 3 kilometers. Dart will have to approach using internal sensors. Yep. Yeah, true that, AJ. So, yeah, make sure you go over there and support NSF. This footage is coming from Boca Chica Gal, so Mary, and also Nick and Sweeney. They're their 2 full-time, that's NSF's 2 full-time photographers down there. You get basically unprecedented access, and then we can stream it, too. So, it's not something they do for everybody, so somebody up there must like me, I guess. Yeah, Ray, definitely helps. Oh, look at that. Did you guys see that? So, Alex, while we're on the subject, and once again, I haven't heard this from any official source. I'm just hearing this through the grapevine. So, the orbital launch mount, you can see it's outgassing, all right? Did you see that pad was outgassing there, right? I've heard that nitrogen is there to spin up the pumps on the outer engines. The outer engines. So those Raptor booster engines are the RB engines, as opposed to the RC engines, which are Raptor center. The Raptor booster engines don't have a way to reignite. They're GSE. They're GSE Raptors. So Raptors that need the launch pad to start. The idea is that you take the starter motor from each of the Raptors. If you put it on the pad, that's less weight for the booster, less mass. So those engines only need to start once, and they only need to start when you get off the pad. The center engines are the ones that need to fire for it to land correctly, right? So the center engines are the ones with relight capability. The outer engines don't have any relight capability. So what I've heard is that they're going to use nitrogen to spin them up. And that's what we saw right there. We saw the outgassing, basically them testing the nitrogen depress system to spin the pumps on the engines to get them started.
Discovery.
Hey, Bio, what's going on? I've heard that too. I thought you'd prefer helium for ignition since nitrogen can form byproducts at high temperature and pressure. You gotta keep it simple. Gotta keep it simple, dude. And, I mean, why else would they be loading copious amounts of nitrogen into the fuel farm? So that's the powerhouse right there with all the electrical equipment. We knew that because when we saw them make this building, it had a bunch of electrical conduits coming into it. Something like that, O-Force. How do you spin the 2 pre-burners evenly? With even pressure? I mean, that's my guess. Once again, I've been hearing that's my sources say thing about starting up Raptors, but that's kind of, you don't need to go no further than Twitter or something or NSF or whatever to get that type of information. I'm pretty sure that's what we're looking at. Because you got to think, why else would you have a crazy outgassing system on the pad like that? Let's use some deductive reasoning. So let's say that's methane. If that's methane, why would you want to outgas methane out the center of the pad like that quickly? Pretty sure it's not that. You wouldn't want to do that with oxidizer either. Because shooting oxidizer like that into the booster makes no sense. either fuel, liquid fuel, or oxidize. That doesn't make any sense. Why would you outgas like that quickly? Why would it come out of the center of the pad? Shouldn't it be on the quick disconnect? If we're gonna talk about outgassing stuff very quickly. And then also another thing to understand is that quick disconnect, you do not want that to leak. Astra had a problem with their QDs leaking and the rocket went sideways. SpaceX had a problem with their quick disconnect leaking and SN4 obliterated itself on the pad. So I'm pretty sure that's not liquid fuel. I'm pretty damn sure it's not oxidizer. So what else is in this thing? What else is in the fuel farm? Nitrogen, right? And why would you shoot nitrogen up the pad like that? That makes no sense unless you were using it to start something. The only way I can think of using that to if you're going to vent at that rate, right? If you're going to very quickly, is to start an engine. That's the only real thing that really makes sense. You wouldn't want to release nitrogen gas like that too quickly. What are you doing? Pressurizing the tanks? Pretty sure pressurizing the tanks that quickly can cause stuff to, right? And you generally wouldn't want to fuel up tanks fast like that either. That doesn't make any sense. A fire extinguisher? It could be a suppressor system, Da Vinci. But A, why would you use nitrogen? I mean, it is inert. You could. And B, why not just use the sound suppressor? They're already spraying water on the pad, so wouldn't you want to use water to do that? I'm just kind of playing devil's advocate there. Why else would you shoot nitrogen through the pad like that? It's true, since each Raptor boost has its own quick disconnect on the side of the booster next to the hold downs. Yeah, Phil, that's right. Not water to the engines. Yeah, so, I mean, it could be a fire suppressant system, but generally don't you want fire on the pad when the rocket goes? You kind of want that, but you want it in a certain area. It could be that. I'm not saying that it isn't. I have no way to prove otherwise, so. But, I mean, Da Vinci, I think it's important to remember that a lot of systems on rockets are there for twofold reasons, right? They're there for, it has dual purpose. So, it could be used for both of those things. You could use it to quick purge the engines, which would be useful if you want to static fire. If you're going to static fire the booster, a quick purge system like that is probably useful. You don't want oxidizer, liquid oxygen, or liquid methane hanging around inside of the engine plumbing, believe it or not, even though it's designed to move it, because liquid oxygen is super corrosive. You have to get that stuff out or the engine will rust from the inside out. Yeah, that's bad. Generally, they purge down engines after they fire them for that exact reason. Oxidizer's super corrosive. Nitrogen is more effective than water for fire suppression due to its temperature and its diffusivity when it's a gas. Yeah. True that. I mean, like I said, I'm pretty dang sure it's for engine starting, but I've heard that from a guy who heard that from a guy. So it could be that too, fellas. It could be either one. I have no way to say otherwise, you know? So that's the thing about doing, like, oh, I heard this from a guy. No, that doesn't really help, you know? So, I mean, a little bit of deductive reasoning tells me it's either for engine starting or for a fire suppression system. I mean, I would guess you'd probably want CO2 for that. Isn't CO2 better for that, Astro? But I mean, genuine question. Maybe CO2 is too complicated. Maybe nitrogen is cheaper, so you'd want to use that. What material do they use to contain the oxidizer? Stainless steel? Stainless. Skydiver. Yeah. Liquid oxygen is fine inside of stainless. It's okay. It's totally all right. Inside of the engines, though, where you have a lot of exotic metals, it's not okay. Like it's reactive with titanium, believe it or not. Yeah, you don't want that. Titanium can be used as fuel. So can aluminum with oxidizer. That's how an SRB works, believe it or not. There's flakes of aluminum inside of the SRB, grain. CO2 causes a lot more byproducts at high temperature and high pressure. True that. How cool would liquid nitrogen be for sound suppression? Well, I'm not sure about nitrogen being able to absorb sound. Water is usually pretty good at that, but yeah, maybe. Yeah, maybe, Leroy. There's the bottom of booster 4. Counterweight is fine for a crane, unless it's not ballast. Ballast implies dynamics. Those counterweights are pretty damn static. They don't move, dude. How does a blast of gas start a Raptor? Spins up the turbo pumps, Spawn. The pneumatic starting system, guys, is not that far-fetched. Look at how big that damn thing is. I mean, that's just the front of one. Look at the people on that thing, man. I still can't believe how big this is. Every time I see it, I'm like, whoa. Because for some reason, like, whenever we look at pictures of this thing, right? Like, when it's just stacked at the pad, like this picture over here, right? You see it and you're like, okay, I think I got a good gauge on how that is. And then you go and see a picture like this and you're like, nope, 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 no I don't. Yeah, Jim, I was saying that. Hey, floating disc, what's going on? Yeah, illness, right? Juan, I'm pretty sure that that's what they're doing, yeah. What are those black hexagons? Procyon, these are tough and unifibrous reinforced oxidation resistant composite. You can call it tough rock for short. It's a thermal tile. So it's part of Starship's TPS, or thermal protection system. These tiles are basically going to resist the heat that Starship will encounter from compressed air becoming ionized and turning into plasma. Basically, air will compress on one side of Starship when it comes back down from orbit. And instead of having a phenolic impregnated or a resin impregnated carbon ablator, right, which is what like a Dragon capsule would have, that basically burns the heat shield, right, to envelop Starship in a nice cool column of gas. These tiles basically push the plasma out and away and straight up resist the heat. That's the difference between a refurbishable heat shield and a reusable system like this. For Starship to fly as much as SpaceX wants it to fly, it's going to need a heat shield that, well, doesn't need to be refurbished after every flight. Basically, land it, inspect it like you would an airplane, put it back on the pad, send it again. Yeah, there you go, Astro. Could be. Just hit spacebar, tap the spacebar once. Yeah, those tiles are almost as big as a soccer ball. Now heavy is one of the hexes. Those tiles have the consistency of styrofoam, so pretty light. When are they planning to launch that? January or February next year, Archon. It really depends on when the programmatic environmental assessment that's done, basically the environmental impact report on launching Starship, whether that goes through. It should be done by the end of the year, and then if that goes through, it should really just be up to SpaceX if it goes through. Has transpiration cooling completely gone from Starship? I'm pretty sure they wrote that off as too complicated, Banya. Transpiration cooling is good, but it really only works in small quantities, like on a nuclear warhead. That looks like the bottom section of 21 right there. Yeah. Booter. No, not really. Chaos. Transpiration cooling is not using water. It's shooting methane out through porous holes in the hull of the ship. Oh, nice, Stormy. That's cool. Good to know. I saw an interesting thing when I was at IAC, and it was a transpiration-cooled rocket engine. I mean, yeah. I mean, that's...
Discovery, go at throttle up.
Yeah, it's doable. Why not? Oh, that's cool, Stormy. Neat. Yeah, I suppose. I mean, why would you? I mean, like transpiration cooling would be cool, but I mean, film cooling would do the same thing. But I guess that really depends on your power packs. It depends on what you're doing. You know, transpiration cooling could be very useful. I mean, if you had an engine that had an autogenous pressurization system, right? But that tap off would go to transpiration cooling through the inside of the nozzle. Yeah, then yeah, that'd be pretty neat. Pretty damn useful, actually. The flames coming out of that Astro would look very weird. They would look very weird. The Saturn F1 was film cooling, guys. A little bit different of a concept. Same idea, though. The idea is that you have a cool column of gas, a cool film of gas between the explodey bits that's coming out of the rocket engine and the outside of the nozzle. Do you think they'll skip to SN21 and Booster 5 if they are ready before the FAA? I don't know, Balk. Transpiration cooling extends the lifetime of the engine by nearly 50 times. Is this the closest thing to an operational SSTO? Starship? Starship could SSTO, Jackery, if you extended the fuel tanks. It could SSTO in its current capacity if it had no wings or anything on it. Yeah, you could probably single stage that thing. But yeah. The thing about an SSTO is that it's like a small sat launcher, okay? If you're gonna make an SSTO, you take a huge penalty. You take a huge penalty on your mass fraction because you don't have the benefits of staging, right? But the benefit is that you get everything back, all right? So when you do something like that, the only way to overcome that crap mass fraction that you have to orbit, basically you're lugging more spaceship into space, and if you're lugging more spaceship into space, that's less cargo that goes into space per mission. The only way you can really get around that is if you launch a lot. So you need to come up with something that's highly reusable, like airplane reusable, or else it really doesn't make sense. And even if you come up with something airplane reusable, right? your SSTO would need to be flying pretty much every day to compete with something like Starship. Starship could SSTO. It could. It just doesn't really make sense to. Earth's grav well is a real big pain in the butt. Basically, long story short, the rocket equation sucks. It sucks. We have a huge grav well on this planet that we have to overcome. You need to accelerate something to 17,500 miles an hour just to get it into space. That's an incredible amount of energy. You need a lot of energy to do that. And if you waste some of that on lugging spacecraft into space, you take a huge penalty on your payload. He did say that on Twitter the other day. Yep. You could single stage a Falcon 9 lower stage if you didn't have a payload. A lot of things could SSTO, but it wouldn't be functional because you're lugging an entire spacecraft into orbit. Once again, the only real way that really makes a lot of sense is if you try to do something like the X-33 or Venture Star, something that's capable of very, 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 very high rate of flights that basically can be turned around in a day. And saying, oh, I'm going to make an SSTO that can launch once a day, right? And has a fully reusable thermal protection system, right, using Hydrolox propellants is like saying, hey, if I had 180 IQ and could bench press 300 pounds, I would be a football player rocket scientist. It's like, yeah, I mean, I guess you could do that. But there's a lot of prerequisites there that need to be in place to get that done correctly. But in terms of answering the question, Starship could SSTO. Sure, it could. It can SSTO on Mars and the Moon. No problem. It's just Earth. Big pain in the butt. That's why they chose to make Super Heavy. I mean, you know, I suppose one could make the argument that making a first and second stage fully reusable is almost as complicated as making just one stage reusable. But also at the same time, you know, SpaceX has very, very high experience with first stage reuse. More than anybody. I think they're the only ones to ever reuse one. Rocket Lab's getting close, but either way, I think that they're gonna tap off that reusability from Falcon 9. Basically, they already know how to reuse a first stage. That's already in the bag. So you might as well just push to make the second stage reusable. You do it, but do it with a clean sheet design so you can build something ridiculous from the start. That's why SpaceX, I don't think they ever bothered with trying to reuse a Falcon 9 second stage. It doesn't really make sense. Yeah, Smirks, that's actually some pretty cool space news for the day. Rocket Lab posted a picture of their new kind of design. .8 chaos, 9.81 meters a second per second, or 32 feet per second if you use freedom units. Technically, NASA has the first stage reusability in the shuttle, because the first stage was basically the boosters. Yeah, of course, but those booster casings need to be towed and they need to be turned and then they need to be repacked. I mean, that's a step in the right direction. I much prefer the shuttle because you get your upper stage engines back. That one is a real big one to me. Yeah, getting those upper stage engines back is probably a good idea. That enables you to make them a little bit more complicated. RS-25. Beautiful. I mean, the shuttle... You know, people say the shuttle's wacky and ridiculous design, Astro, right? But, all right, how else are you going to do that? How else are you going to do that and, you know, not have ridiculous problems associated with second stage reuse? Everyone's like, oh, just put the shuttle on top of something. Oh, okay. Sure. Just put a Saturn 1C, an S1C. Put that underneath the external tank and do that instead of the boosters. Okay. Sure. Yeah, there's a reason why NASA didn't do that. But it works in KSP. It does. We did test it. It does work. Oh, okay, Smirks. Yep. Or just use an external... Oh, yeah, let's just make the external tank reusable. Sure, no problem. Yeah, I'll get right on that. I agree, Sile. Yeah, it's going to be awesome. What do we got here? Actually, NASA's original idea was to put the shuttle on top, but the way they packed it, the way they packed it was because they could use the RS-25s for both launch and space. Yeah, got a little bit of problems associated with that. Having those engines fire so far up the stack would be a little bit of shear load on the stack during liftoff. Yeah, I'd prefer the boosters. I think the way the shuttle was designed was just fine. You know, spray on foam insulation cavitation notwithstanding. Actually, you know what would have been a good idea? Making the external tank out of stainless. Making it out of this would probably be good. You notice that Starship doesn't really ice over until it's depressed the fuel? That might not have been a bad idea. I like the way Buran was designed. Yeah, but you don't get your upper stage engines back. There's Booster 5. Once again, the AP lines aren't hooked up. There's your oxygen autogenous pressurization lines. What is this? Booster quick disconnect hood. Oh, that's the cover for it. Cool. Cool. Laughs at Energia too. Yeah, implying that ever could have been made. Okay. The Energia booster could have been reusable. I mean, like Astro, yeah, I guess, man, it could have been, but saying that the Energia core stage could be reusable is like saying they could have made a thermal protection system for the external tank and made that reusable. I mean, like, I guess. I prefer the shuttle's design, to be honest. I want my upper stage engines back. I mean, the Energia lifter in itself is really good because you can move shuttles or cargo into space, right? But if we're going to go off of, well, they were going to do this, well, NASA was going to do Shuttle C as well, which would have turned the shuttle stack into a heavy launch vehicle in general. So you could have had shuttles and heavy cargo, Saturn V tier cargo being brought up, and then the shuttle could assemble it. Like, if we're gonna play off, well, they could have done this. Well, NASA could have done Shuttle C, and I'd argue that Shuttle C and the shuttle is a better design than Buran Energia, but that's just me. I still think Energia is one of the best vehicles ever designed. It's a great integrated system from the start. All right, Cammy, see ya. All right. We got one more. Oh, no, I think that was it. I think we got all three of these. Was that the one that we just saw? Let me just make sure. Nope. We haven't seen this one yet. All right, let's check it out. Once again, this footage is coming from NASA spaceflight. Let's see. Why are we defaulting to 360? Please stop. Smirks, oh, I do not have that. Yeah, okay, cool. When hop? February, January or February. We're waiting on the EIRs, basically. For what it's worth, I've read the programmatic environmental assessment. We went over it on stream. It's pretty good. It's pretty damn comprehensive. I mean, EIRs aren't just about appeasing hippies, you know, like. I mean, even though that is some of it, but it's not just about that. It's making sure that you don't build a castle that's gonna fall into the swamp. Ha ha ha! They said you couldn't build a castle on a swamp, lad, but I built it anyway. It fell into the swamp. So I built a second one. That fell into the swamp. So I built a third one, lad. That burned down, fell over, then fell into the swamp. But the fourth one, that stayed up. But father, I don't want any of that. One day, lad, this will all be yours. Oh, what, the curtains? No, not the curtains. Father, I just want to sing. No, you're not breaking into song up here. You don't like her? What's wrong with her? She's rich. She's got huge tracts of land. No singing. No, seriously, all right. EIRs are there for that exact reason. You don't want to build something that's heavy on swampland and then have it fall. You don't want it to Millennium Tower, to speak in Bay Area. Am I too European to understand that one? It's Monty Python. Sure. Water pipes. Okay, alright. Hip, but we don't want to use the Millennium Tower. Leaning Tower of Pisa? Leaning Tower of Pisa is a good reason why you do EIRs. That's a reason why you do EIRs, so the thing doesn't... You know, yeah, that's probably not a good idea. I agree, Stormy. It's pretty cool. Yeah, that looks to be the water system right here. This pipe that's made out of the black iron pipe. See how it's dark? It's called black iron pipe. What's an EIR? Environmental Impact Report. That's what SpaceX is waiting on right now, Ice. That's why they don't launch anything. That and the pad isn't finished, but... The technical term for it is the Federal Aviation Administration's Programmatic Environmental Assessment. So that just happened. Oh, cool. So it's a permit. Yeah, for the most part. If you want to boil it down to its base element, yeah, sure. That's what SpaceX is waiting on. And then once they're ready to go with this thing, then they're going to launch. They're not just going to launch a hop. It's not just a Starship. They're going to put Starship on its first stage, super heavy, and send that thing. Which is... I mean... That's going to be a big deal. Ferd. What's been most impressive is the speed Starbase has been coming together. I mean, Mary has a new vid every day. Yep. Yeah, it's going to launch off of this sucker right here. And then eventually they're going to try to catch boosters with this thing, which is just, all right, also Ferd. What's that porta potty doing next to the Ford? I don't understand. See, fuel lines right here. See these two big things right there? That's the liquid fuel and liquid oxygen lines right there. So liquid methane, liquid oxygen lines right there. The reason why they're on this big bendy hose is because this whole thing will pivot. It'll go like this, back and forth. So this section will stay flat, right? And then you can see where the lever arm is. It'll go. It's basically, you know what, guys? That looks just like a bigger version of Falcon 9's quick disconnect. It looks exactly like it. It's just bigger. And I've noticed that they fuel liquid fuel and oxidizer through one umbilical, which is not something that's generally done a lot. Usually you separate them out. The reason why you separate them out is because you really don't want your liquid fuel and oxidizer mixing anywhere but inside of the rocket engines, and keeping them near each other like that kind of runs the risk of, you know, them mixing at a time when you don't want that. But, I mean, clearly SpaceX ain't worried about it because they're doing it, so. That looks to be the case, Hellfish. This is kind of, no, yes and no. See, Super Heavy uses a different type of connect system There's a different type of hold down point system than Falcon 9. Falcon 9's hold down points are on the sides. Super Heavy is on the bottom. And then Falcon 9 has 2 tail service mast umbilicals that are at 1 o'clock and 7 o'clock. If you know, they have hold downs at 12, 3, 6, and 9. Actually, I can just show you. It's way easier this way. Let's go here, Rocket Research Pictures. Let's go here like this. So there's the hold down points, right? This is the strong back that was photoshopped for Falcon Heavy. I think Ian photoshopped this way back in the day. So you have your hold down point right here. That's what this big sucker is. This little guy right next to it is the TSM, tail service mast. Tail service masts are basically a nice way of saying where the fuel and oxidizer is loaded. They load one on one side and then they load one on the other. So Falcon 9 has hold downs at 12, 3, 6, and 9. Now, once again, this is in Falcon Heavy configuration, so there's no 9 here. But you still have load points at 1 o'clock and 7 o'clock here. The Space Shuttle used separated TSMUs. Falcon 9 does. Delta does as well. So does Atlas. They're all different at different points. It seems like SpaceX combined them into one thing. But see, this thing, Falcon 9's TSMU goes vertical. It's straight up and down on both sides. So those tail service mast umbilicals actually go down, and then that cover folds over, right? So you don't get blasted. So you don't blast the connection equipment with rocket exhaust. Same thing with the hold down points. But the hold down points inside of these armored boxes, they actually move like that disconnect. They're in like this, and they hold Falcon 9 on its hold down point, which is a peg that goes horizontal, and then they go like this. And then when the latch opens, right, the entire thing moves backwards. That's what the quick disconnect is like. It's like Falcon 9's hold down point. It is much more. It looks a lot more like this than it does like that. I know, yeah, Zin, right? It's pretty nuts. Let's see if we have another picture of it. Yeah, that's at Vandenberg. It's a picture from the other day. There's Dragon integration. So that's the hold down point right there. Keep in mind this is on Falcon Heavy, and then there's your umbilical attachment point right there. See, the hold down point is like 2 like hooks that kind of go like this, right? That pin is right here, and they kind of go like that, right? They go on either side here. And then when Falcon 9 goes, they let it go, and then the masts go out like this. You can see there's another pin over there. And then there's your umbilicals. You see they have them pressurized to keep tank pressure, because you have to keep the tanks pressurized when they're on their side. They're probably pressurizing with nitrogen or helium or something. So stronger than the clasp on your trunk. Yeah. Those are pretty strong. Those pins are about this big. I'd say, I don't know, 5 or 6 inches at least, which is like 150 mil or something like that. There's 4 of them. And then on Falcon Heavy, they have a clip that holds the 2 hold down points together here. And then that gets put on a pad right there, because you don't want these separating when you lift off, right? It goes on a pad right here, and that pad is sitting on what's called a compression bridge. I have a picture of the compression bridges right there. See those things? That's designed to hold up the rocket when it's fully fueled, because it's a little bit heavier than Falcon 9. I mean, heavy is in the name. Maria, privet. Как дела? How are you? But yeah, it seems like the super heavy disconnect does something like Falcon 9's hold down point. So it actually, it'll go like this. It'll pivot backwards. Man, those flex hoses though. That braided steel hose, man. It's like $5,000 worth of hose right there. That's crazy. Yeah, see, once again, these are valves, but I'm not sure what's going on here, to be honest with you. I don't know what any of this does. Yep, stick weld in the black iron pipe. Did you see this from Nick today? A new pipe section being installed. No, I haven't, but I'll check it out. I've never seen flex pipe that thick before. It's pretty chunky, isn't it? Space grade garden hose. Yeah, it's a beast. It's a beast. No doubt. I'm going to go ahead and guess that the black iron pipe is for water deluge. Yeah, Evil, I would say that's correct. 1977 on the tag on the trailer, so I mean it says liquid nitrogen right there. But 1977 is liquid nitrogen. If you look at the handling tags, I've talked about these before plenty of times on stream. If you ever see a truck and it has these numbers on the side, that's an indicator for what the thing is hauling, and the placard represents different things. So what the idea is that you obviously indicate what you're carrying, right? That probably should communicate that to people. That probably important. Second thing is for firefighters. These are for firemen. So if this thing catches on fire, they know what to use against the fire. Because if this number said 1993 and it was on fire and you sprayed water on it, it would do nothing. It would make the fire. It would oxygenate the fire, which is worse. 1993 is diesel. Yeah, you don't want to put water on that. That oxidizes the diesel fuel. Bad idea. Or if it was like fuel oil or something, yeah, this tells the fireman what to use on that fire. Hey, Klein, what's going on? Another one. Hey, baby. Oh, they're filling up the suborbital pad too. Man. Yeah, right, Hired? It is. How many of those codes do you know? Off the top of my head. So 1203 is gasoline. 1977 is liquid nitrogen. 1993 is diesel. I think 1990 is fuel oil. So like for heating a house. I think oxidizer, liquid oxygen is 1203. No, not 1203. 1202? I forget. I don't know a lot of them. Only the ones that you really see driving around. Like I see gasoline trucks and diesel trucks and fueling oil trucks driving around. 1202, I think, is... Hang on. I can check. Here. Take a look. So 1977 is liquid nitrogen. 1978 is propane. 1963 is helium. Cryogenic helium. Oh, yeah, I see. Huh. Selenic acid is 1905. Okay, remind me to never go near one of those. '64 is a hydrocarbon gas mixture. Compressed nitrous. Yummy. 1966 is liquid hydrogen. 1971 is methane or compressed natural gas. 1977's nitrogen. We already said that. Yeah, look at all this. $12.01 is fusel oil. $12.02 is gas, diesel fuel, or heating oil. $12.03 is gasoline. Man, look at all these codes. $12.23 is kerosene. So that might be what an RP1 truck would have. Just getting off work yesterday, I had to make a heartbeat decision to put our 7-year-old cat down. Oh, that sucks, man. It sucks when you have to put pets down. It's the worst feeling ever. 1267 is crude oil. There's shale. 1288. 1299 is turpentine. Nice. How does a firefighter remember all of them? Firemen don't remember all of them. There's visual indicators, Tomas. There's pictures. There's pictures on the placards too that say don't do this. That's how you remember. Or I mean, you look it up. I mean, you could just have a manual inside of the truck just in case. But yeah, you generally want to know what type of fire you're fighting against. It's actually one of the tough parts about being a fireman. I mean, you have to sit there and you have to make like a split-second decision analyzing what kind of fire you're putting out. What are you dealing with? You have to assess it kind of like a flight controller, like if something happens on a space flight mission. You have to assess the conditions, and you have to kind of make a split-second decision, but you also can't. You got to make sure you don't screw up. I mean, you choose how to fight that fire, or sometimes you can't fight it. Sometimes you just contain it and you let it burn itself out, which sucks. But I mean, if you have like an oil fire in a building, there's not much you can do to deal with that. Just make fire breaks at the right spot, keep people away, and just kind of let it do its thing. There's only so much you can do. I mean, a pump truck and the fire hydrant's only going to do so much. Sometimes you don't even spray the water at the fire. You spray it next to it. Sometimes you spray it on top. Sometimes you hit it at the bottom. It really depends. Yeah, being a fireman ain't just show up, put some water on it. Okay, save the cat from the tree. We're good. I mean, once upon a time, your boy took the fireman's exam. It's a lot more complicated than you think. It really is. It's tough. I'll make it. It's your wife you're worried about. Had to make decision for... that sucks, man. Yeah, freaking fire could be too much. You just kind of got to let it do its thing and just leave it there. How bad did you fail it? I actually passed. I got an 88 on the fireman's exam. Yeah. I didn't fail it at all, Silkbox. Sometimes to put out the fire, you have to use explosives. Sometimes to put out the fire, you need to use two jet engines mounted on a tank. Fun story. Yes, you're looking at that correctly. That's a T-34 with two MiG engines attached to the side. They use this to blow out the oil fires in the Middle East. So during the Gulf War, for instance, right, they lit the oil wells on fire because screw you, right? And the Russians cooked this thing up, and they took the turret off of a T-34 and put a mount basically put the back of a MiG on this thing instead. It works. There's a fuel tank right there. It works great, actually. It blows the candle out. Hey, can't have a fire if you can't have a fire in a vacuum. Straight up, you move enough air, you're going to create a vacuum and put the fire right out. And it worked. Worked great, actually. This is one of those things that I want, but I don't really understand why I want this. But I still want it. Yeah, it could be a T. Yeah, it could be. I'm not sure. I seem to remember that it was a T-34, but I could be wrong. Yeah, it's jet truck in real life. Yeah, that's where I got the idea, man. It works. It works great, actually. New sub goal. No, I'm good. It's the Tim Taylor. I don't know why I want that. I don't know what I would do with a jet-powered tank. But I don't not want it either. How bad is the recoil on that tank? Yeah, it's fine. It's fine. It's fine. Huh. Wait, what ship are we looking at here? Why? What's this about? Remind me of the flamethrower that DeBoss has. Yeah, DeBoss does have a Sherman tank, doesn't he? That's kind of cool, man. That's kind of cool. It's pretty sweet. It's a T-35 and Hungarian, not Russian. You would know that. The holes are for more TPS. Yeah, Astro. No. Yeah, no. You're right. Absolutely. I'm wondering why it's asymmetric. See what I'm talking about here? Why does the starboard side have these holes, but this side doesn't? You see what I'm talking about? I wonder what that's about. I mean, Vanguard, what are you saying? I don't know. They probably just haven't drilled them yet. I mean, this is on 21. This is the one that's out in the field, Astro. Yeah, maybe. It's very interesting. Camera right there, from what I can tell. Someone didn't color inside of the lines. Yeah, right. I mean, is it bad if I had an Abrams tank? I don't need the gun. The smoothbore is cool, but I don't need that. I don't want. Just take the turret off. I just want the chassis. That's that. I mean, I don't. The gun is cool. Like, I'm not gonna say that I don't want that, but also just the chassis would be neat. You just put a hole over where the turret is. Just seal that up. It'd be fine. I mean, if I had a like, it's just a. I mean, what? It's a tank chassis. What are you gonna like? What are you not gonna do with it? Like, it's faster without the turret. Damn right, man. I don't need that. Yeah, fewer things to break. The best part is no part. But then again, can't really fight so much. Like, I don't need the gun part. That's fine. I don't need that. That doesn't appease me. That's not appealing at all. I want the tank part, like the bottom part. Yeah, get one of the towing maintenance tanks. That would be cool. That would be cool. If I lived like on a farm or something, Leroy, I honestly would. You can buy them for not a lot. There's that person doing work right there. Yeah, they're winched up, Xeon, so it looks like they're priming up the suborbital pad here. At the launch site, guys, they have two fuel farms now. There's the one that we watch from the hops, and then there's the big one over there. I don't think they're connected to crossfeed at all. I'm pretty sure they aren't, or otherwise they'd have one fueling location. See the truck? The M88? Yeah, pretty much. Yeah, I'd be cool with this. This is fine. That looks to be exactly what I'm thinking here. Yeah. That's a 155 howitzer, and it just lifted it. Yeah, see, I want this. This is that. You know, the Abrams is nice, but I prefer this. That's cool. It's cool. It's got a big A-frame on it. It can lift stuff up. Hello. Oh, that poor Deuce. What happened to it? Yeah. See, it's the. What'd you do? How did you manage this? What? You know what? I don't want to know. See? Yeah. See, this is useful. I like this. I like this is nice, but I like this. And what once again, what am I going to do with that? Don't know. I don't have a reason to want that. I mean, that's probably why I wouldn't buy one. But also, that's pretty freaking cool. You know what I do? I just lift my trucks up. Just lift the truck up and just be like, hey, look what I did. Physics and stuff, right? Like, you can't tell me that wouldn't get views on a Twitch stream. Okay, so looks like the booster here has the umbilicals installed. There's the umbilical carrier plate on the booster. And it looks like there's an autogenous tap-off line to keep the tanks pressurized. See these hoses that are coming off here? This is the autogenous pressurization system. And once again, every other one is, so it's methane, LOX, right? Or gaseous methane and GOX, I should say. Gaseous methane, gaseous oxygen, gaseous methane, gaseous oxygen, etc., etc. And it seems like there's a cap right here so they can keep the tanks pressurized. They're probably pressurizing them with nitrogen or something. But it's interesting that they tap into the autogenous lines right there. That's very interesting to me. And it looks like that might just be temporary for this booster. If I had to guess, SpaceX is probably figuring that into the umbilical. You seem to have the same diameter pipe here, 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 and here as you do it here, here, and here. So this part is probably just temporary. Either that or they use it for booster transport, because it very much looks like there's a tap that goes into the autogenous pressurization down here. But once again, that's a T-pipe. That's not two lines. So I'm not exactly sure what's going on here. But that's Super Heavy's carrier umbilical. That's what goes into the thing that I was talking about. Yeah, see, there's your main LOX input and main methane input. It could be reversed, fellas. I'm not 100% sure. I'm gonna go ahead and guess that. I don't know. Yeah, it's hard to say which one is which. Yeah, Xeon, I know what you mean. It's starting to look more like a rocket. I'm with you. Here's the high bay. You'd use it to launch your own rockets? I mean, yeah, that'd be... I want it. I like that truck a lot, man. Oh, I'm sorry. I don't mean to cause a tangent. That's a nice dude. An F-150 with a step side. Yeah, I don't hate this. Do you think a wet dress rehearsal is possible for the end of the year for the stack? I would certainly want to test that. No, EJ, you can't have that truck. You shut your dirty mouth. Oh, that thing is cool. It's the step side, man. It's the step side F-150. That's really neat. I really want it. It's a 95 too. Oh, that's a cool truck. I want it. I want it a lot. Can I have it, please, chat? Please, chat. I need this. Step side or dually? That was a step side. Whether I would prefer one or the other, I don't know. It depends on the application. So when are you buying a multi-story car park? Yeah, when I hit the damn lottery, Geeson. What does Brimo say? Nah, I already have one. I have a better one than that anyway. The first step is admitting you have a problem. Oh, I admitted that like months ago, Matt. I have 4 automobiles, dude. I have what's called a carcane issue. But it's fine. It's fine. Yeah, look at that. Wide bay. It's coming along real nice. Did you just... We already have a truck at home? No, I already have 2 trucks at home. Yeah, mine's better than that. Yep, those guys are getting all the nuts and bolts in there for the flying buttresses. Nice, Alex. There you go. Now, what do we got here? Okay, we got forms right here. See the wood? We got forms going in right here, and then you got rebar. Concrete foundation. I'm not sure what it's for, though. This is... Is this behind the mid-bay? Buttresses. Check out this neat browser-based Starship game. Oh, ha! That's cool. This is behind the high bay. Interesting. Yep. These guys are laying down rebar. So rebar is just... Truck. So rebar like this is basically gives the concrete something to kind of adhere to. You'd put... The idea of if you put a metal lattice inside of concrete, you create what's called reinforced concrete. Basically, it's concrete with an iron endoskeleton. Or a steel endoskeleton inside of it. It's very, very strong. Designed for holding up stuff that's really heavy. Now, if you were just... If this thing wasn't... If you didn't see any rebar here and you just had the concrete forms, it would be like a concrete road. Concrete roads don't really have reinforced steel inside of them. This thing, whatever is going to be here, is going to hold up something that's heavy. The lattice system reinforces the concrete. So you, once again, holding up something heavy. My guess is that it probably has something to do with space. Just putting it out there. Rebar is a composite and you can't convince me otherwise. You hate concrete roads? What? What's the matter? You don't like the tuckle, 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 tuckle noise when you drive over them? Tuckle, 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 tuckle. Adds torsional strength a little bit too. Concrete hates shear and torsion, for real. Tuckle, 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 tuckle. You know that noise. You know exactly what I'm talking about. You hate that noise? Tuckle, 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 tuckle. Juice spot, nice. Why do they make that noises? It's because concrete has to be cast in segments. You have to cast it in segments and then you put grooves in it, Sawyer, for water to drain. And either you're hitting a segment, you're hitting a seam, right? Or you're hitting the groove. They put the grooves in the concrete on purpose so water can get away from it. And that thunk noise is the sound of you going over those grooves or the segments. It's the sound your tires make. Thump, 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 thump. The thump noise helps blind people know they're driving on a bridge. I don't think that's how that works at all. I thought the grooves were for traction. On certain concrete surfaces, Vin, yeah. But we're talking about grooves that go left to right, not forward and back. Grooves make a noise. Those grooves are more for crack mitigation. Yeah, maybe. Speaking of which, why do drive-up ATMs have Braille? So they can make one type of ATM machine for a drive-thru or for a walk-up? The real groove is the friends we made along the way, indeed. There you go, James. Yeah. When your wife makes you mad, I drive on the rumble strip for like a mile. When I do that, I go, hey, Brimo, And she goes, yeah. And I go, no, you can't do that. You can't just drive on the side of the road. And then I go, ha ha ha, rumble strip, go burr. And then I drive on it and it goes, yeah, 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 memes. Yeah, I did that during Route 154. It was pretty awesome. I got another booster ready to go. See, there's your methane autogenous pressurization line. See how, if you're looking at the top of this thing, they're at 12, 3, 6, and 9. But at the bottom of the booster, we had one pipe here, there was another pipe here, there's another pipe there, there's another pipe there. They were in 8x symmetry, so to speak. Which, you know, this tells me that 4 of these lines go all the way up are for the autogenous pressurization for the methane tank, and then 4 of them stop halfway up the booster oxygen tank. I'm sorry, were you trying to sleep? Yeah. Yep, see, the oxidizer pipe stops halfway up. There you go. Truck. Anyway, I think the highlight of this whole thing was that really awesome 95 flare side right here. Yep, that was the coolest thing to see in this video. Yeah, see, it's really nice. It's a flare side XL. It's got the bars in the back. That's pretty rad. Yeah, that's pretty cool. I like this. It's a nice truck. Mine's better, but I still like that one too. Yeah. My goal is to someday have every type of a certain year of truck, because that'd be cool. See all the different examples. Don't ask me why. I'm not gonna sit here and even try to pretend that that's weird. That's normal behavior. Okay? It's very weird. Don't know. Don't want one. Anyway, let's pause that and pause that. Let's go to a little bit more space news here. A little bit more Starship stuff here on the docket. And then there's some Rocket Lab stuff, and we have some news from the Russians over there. And then Blue Origin, there's some Blue Origin news. That's good. And then more crap posting by Elon Musk. All right. You cover Peter Beck yet? I think that's what everybody wants to see, but we'll just hold on for a second. Here, check this out. Nick and Sweeney took these pictures today. We'll probably see them on tomorrow's Starship news, but there is the Starship umbilical disconnect, which is in a star pattern almost. Huh. 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 Okay. I'm going to look at Nick's picture here. Huh. Interesting. What the heck? That's very strange. That's a very strange umbilical. No, not sunk into the field geese, and they would be inside and in immaculate condition. What is supporting the booster when it's standing on the launch mount? When it has thermal protection around the engines? That's actually a pretty good question. It's hanging on the outside rim of the booster, Rainy Boy. Yeah, the engines are kind of hanging. So here, I'll show you. If we're looking at super heavy from the side, you have the outside, right? And then, right, like this. So down at the bottom, right, there's the bulkhead for the bottom of the LOX tank, right? And then you have a structural piece right here that holds your inner engines, right? And then there's another structural piece that's right in here that holds the outer engines, right? And this is super heavy. Starship has something similar to this, but it's not exactly the same. right? And then right here, your heat shields would be right here and right there, right? And then, the rim goes like right here, right? So this stops basically right there on either side for the most part. So we can see those heat shields, right? And then the orbital mount, if this is the orbital launch mount, like this, right? And say this goes around in a circle, right? It has a pivoting arm that pivots right here that holds the booster up on the sides like that. And when the booster goes, these arms actually pivot this way. They pivot out and in, and believe it or not, they'll pivot into the orbital launch structure. So this thing will be higher like this, and they'll pivot up and in, and they'll close. You see that? So they're kind of holding on the rim of the booster. Kind of like Soyuz? Not really. No. Not exactly. Soyuz is held up here by huge long arms like that. And those arms are on a pivot and a counterweight. Like this. And when Soyuz goes up, the counterweight actually moves, right? Because this weight pushes it down, and then that's your pivot point. It's kind of like that, but a little bit different. I mean, this is down at the bottom of the rocket. Similar idea, though. Hey, Rocketology, thanks for the raid. NMGB at a 38-month resub. Go Dart. Double asteroid redirect. Yep. Yeah, no problem, Rainy Boy. Guys, I want to get on to the other news, but I'm looking at this umbilical here. There's a lot of stuff here that is very strange. Like why they have 4 trailer hitches mounted on the umbilical. 1, 2, 3, and 4. Notice that? There's literally 4 trailer hitches. They're not trailer hitches, but they look like them. Another good picture from Stargazer. Starship Gazer. Let's take a look. That's really interesting. I've never seen an umbilical like this. But I see what they're trying to do. I see what this thing is trying to do. I mean, it looks like a squiddy from the Matrix. It's guide pins. The trailer hitches are likely the connection mechanism. Well, something else that I've noticed here. Starship Gazer's picture is a little... the contrast is a little bit higher. Something else that I've noticed here. See these pilot dowels on the outside? So there's 6 of them. 1, 2, 3, 4, 5, 6. It's on an actuator. This is an actuated mechanism. So this thing goes in and out. What? All of this, guys, all of this mechanism looks like it's using something similar to a docking port. You have a piloting system for a soft capture. The trailer hooks guide you in, and then these things retract. The trailer hooks guide it in, line everything up, and then these hooks hold the umbilical together. You have a soft capture system and a hard capture system. Now, why? Why would you do that? Why would we need this to be like a docking port? Anybody know? I see what they're doing here. I get it. I'm wondering if you guys know why they're doing that. Why would you want this thing to dock? Like, what? Refueling? That probably has something to do with it. Core space, you got it. Autonomous reattachment. No people involved. This thing will automatically dock to a Starship that's been stacked on the pad by itself. It has the pilot mechanisms and the retraction hooks to be able to soft capture that umbilical onto a Starship down here by itself. You don't need anybody. It's all automated. That's why they're building it like that. Most other umbilicals, you have people kind of attach it, and then, they'll bolt it into position using an explosive bolt, and then the umbilical. Or if you're SpaceX, they have a mechanical retraction system on Falcon 9. Check that out. It's literally built like a docking port. Now, a lot of people did say, you guys were saying, well, This would probably be useful if you're trying to refuel on orbit, making your fueling umbilical like a docking port, because that means all you got to do is extend one of these on a starship, find another starship, and then you use what? You use a docking system. You can use Dragoneye to do it. You could use Dragoneye to get these things to attach to each other. Certainly looks like what they're doing. That's nuts, man. Look at it. Look at those hooks. It's got a soft capture mechanism. Now, once again, knowing SpaceX, this is probably a prototype. They would probably want to figure this out down here, because if you're automatically docking it down here, you could probably use a similar mechanism up there for an automatic docking system. Now, the real question is, how the frick does this thing move by itself? What's the actuation mechanism, and how does it locate and find where it needs to go? It's a very interesting thing. It's amazing how docking has similarities to how cells interact in biology. Really, Grog. Dude, bio is not my strong suit, but that's actually really cool. There's weird... I've noticed that, though. The more I learn about physics, the more I see just patterns everywhere. Everywhere. They're all over the place. Yeah, it's very strange. There's patterns everywhere. It's optimizations. Yeah, refined over time. Yep. Crazy. But it's crazy how everything ends up with it's the similar pattern everywhere. It's very, very weird. Golden ratio, yeah. Yeah, it's pretty insane. I don't know if these are cameras, dudes. I don't know what those things are. I couldn't tell you. Yeah. Lord, yeah, Dude, it's very strange. It's very strange. I mean, yeah, it's very weird. I had a dream you were playing Summer Car and you were eating stuff from the market so it wouldn't expire. That probably is what's going to happen the next time I play Summer Car. I'll be honest with you. But yeah, look at that. They have trailer hitches attached to the front of the damn umbilical. That's just a trailer hitch, man. Look. Hey. There's labels here. There's labels. Liquid oxygen tank, fill and drain valve. Methane fill and drain valve. What's this one? CH4 ground bleed. There's your recondenser line. I don't know what that says. Something purge. What about up here? Everything is labeled. Oh, this is super helpful. Thank you. Thanks, Nick, for these frigging pictures, man. Or this is Starship Gazer's pictures. And Nick, too. Starship Gazer, we can actually read what all this says. So there's your main LOX line. So it's LOX is on the left. Methane on the right. Can you paste this image? Sure, dudes. Make sure we give credit where credit is due. Starship Gazer. There you go. Link is in chat. Help me figure out what this stuff says. That's CH4 ground bleed. So there's your methane recondenser. This is into something purge. So that's main LOX line, main methane line. This is LOX tank. And yeah, I can't read those. I can't see what they say. One more. Oh, RGV has some really good pictures. Let's check that out. So CH4 tank pre-pressurization, LOX tank pre-pressurization. Helium fill and drain, CH4 igniter fill and drain, gaseous nitrogen fill and drain valve, high voltage right there, whatever that is. So that's electrical power. Hang on, let me go back over to gazers. So this is above the top right trailer hook. Ignition, fill, and drain. Interesting. Interesting. There's a large white transport aircraft flying over Lompoc. I've never seen it. Wondering if you knew anything about it. Does it look like that? Those pinned at the ends of the 6 arms, legs. Makes me think they want to disconnect at a certain angle. Smuck, that looks like a soft capture mechanism. Like think like a pilot dowel. Like when you're putting a transmission to an engine. Same idea. Nope, not that. I don't know. White usually is a NASA plane, but it's very, very interesting. Yeah. Hey, Grog, 2-month resub. Thanks, dude. Hell yeah. Huh. It's interesting to me that these are the same diameter. The methane and the LOX are the same diameter. Usually the umbilical diameter is correlative to your fuel ratio. What does that mean? So the liquid oxygen tank is actually a little bit bigger on Starship. If you look at Starship's LOX tanks versus the methane tanks are a lot smaller. You'd think that the methane line would be smaller than the LOX line, but they seem to be similar, which tells me that you have differential flow rates here, meaning that the oxygen is flowing faster than the liquid methane, which is interesting. Yeah, that's the line for the recondenser, but yeah, once again, look at those hooks, dude. CH4 ground bleed and LOX tank fill and drain. You have 2 CH4 ground bleed lines. Huh. Yeah, if you standardize your fitting, Subcom, but that could have problems elsewhere. And here's the booster one. Look at this. Who took this picture? Golden Boy? A Lab Padre commentator currently battling a major SpaceX addiction. Yeah. Aren't we all? Yeah. This is a different. They have different attachment systems. It's probably because they need to flow a little bit more fuel into Super Heavy than they do into Starship. My guess is that they would have a different carrier umbilical for Super Heavy because, once again, you need to flow more fuel, so you need bigger fittings, you need a bigger plate. But the idea is the same amount of holes. LOX pressurization, fuel pressurization. So LOX is on the left. The LOX is on the left side on Starship and Super Heavy. LOX left, methane right. The tweet below that has labels. Oh, perfect. Yeah, look, see? They put spares on there because they might need stuff for different things, huh? Or, oh, those are the alignment pins. Interesting. Interesting. That's the trailer hitch pins. Interesting. That's cool, man. So, Astro, if you're still here, there is some helium in this system. We have some... So we have helium, gaseous nitrogen, gaseous oxygen, so gaseous helium, gaseous oxygen, gaseous nitrogen, liquid oxygen, liquid methane, methane pre-press. Interesting. That's pretty rad, man. It looks like Starship is similar, but it looks like Starship is flipped on its side. It looks like a very similar umbilical, but flipped in a... No, they're dissimilar. There's no way these are the same. Yeah, see? Everything here, see these pins? They retract. So everything here is supporting a soft and hard capture mechanism, which is very interesting. I wonder why these are so far away like that. I mean, I'm sure there's a very good reason, but also, what is this thing? Cameras, maybe. Are those cameras, fellas? I don't know. It might be a camera. It looks like there's a lens on it, and you're going to need some type of thermal protection because it's going to get very cold right here. Lights could be a light. One of them could be a light. The other one could be a camera. But they look pretty dang similar. So whatever it is, it's two of the same thing. Man, dude, this thing's gonna straight up look like Gladys when it goes to attach. It's gonna be like click. It's gonna look like freaking Gladys. I mean, it already does kind of look like Gladys. Look at this thing. That looks like something from Aperture Science, man. You have selected gaseous methane for your recircularization system. Now I'm going to connect to the Starship and launch it into space. Something that you don't get to participate in. Because they have cake in space and you didn't want cake, so you don't get to launch into space today. You don't get to launch into space at all. There is cake in space, and you don't get to have any. Oh, it's you. Remember that? I was all like, you can have cake, and then you were like, no. There was venting from inside the pad. People were claiming that the engine's quick disconnect were the source. Reminds me of the Falcon 9 hookups you were showing. You know anything about that? It looks like they're using something similar to that self-synthesis, and it looks like they're using gaseous nitrogen, so the outside Raptor boosters are started up by GN2. That's what it looks like, but I don't know for sure. Is it yellow cake? He bought some yellow cake. Are you sure it was yellow cake? Yes, I'm sure, chat! Interesting. I'm going to have to read more about that umbilical. Anyway, so check this out. Thought you guys would want to see this. This is a pretty cool little visualization here. So NASA Ames have been using their supercomputers to do some computational fluid dynamics. They're basically doing simulations to see how stuff kind of interacts when it flies through the air. Check this out. They did this simulation for Orion's launch escape system. So watch this. Well, that's playing hell with the encoder. Wow. Okay. Gladys just wants to go back to the moon. It must be the Space Core attachment. Yeah, chat, you know, chat, chat, I want you to just perform one little test because, chat, you might have a slight case of severe brain damage, but don't do anything. Just all right. You just need to test to make sure that you're all set. So, chat, I just want you to say apple. Chat, just say apple. All right, jumping. What you're doing is jumping. All right, just say apple. Just APPLE. It's a quick and easy word. Have you ever done a Portal or Portal 2 playthrough on stream? No, I don't think so. I just need you to say apple. All right, jumping will do. Jumping will do. It's fine. This is art. Observe art. This next test is very dangerous. To keep you calm in the face of almost certain death, smooth jazz will be deployed in 3, 2, 1. Okay, anyway, that CFD is actually really cool. So this is modeling the gases coming out of the engines. It looks like the colors are representing different pressures of the gases here. Note how the gases come out at high pressure and they start to diffuse into low pressure, and then when they hit the actual thermal shield of the Orion capsule. See how there's kind of a pocket of air that kind of gets stuck. See that right there? That's what happens when spacecraft re-enter. The plasma never actually touches the heat shield. It's just next to it and it burns. See that little pocket of air right there? Look how the gases coming out of the launch escape system, they repressurize. It goes back to high pressure when it bounces off the Orion's thermal protection system. See that? Very interesting. That's cool. And look, then it depressurizes and then look, man, that's really freaking cool, dude. I don't want your dang lemons. What the heck am I supposed to do with these? Demand to see life's manager. Yeah, see? So we got a lot of pressure, starts to diffuse, high pressure again, starts to diffuse again, and then it starts to equalize down here. See how the waves get a lot thicker? See? See right there? Very high pressure. That's the overpressure event. That happens when a rocket engine fires. It compresses the air against the gas. See that? That's actually really cool. There's your overpressure event. This is what happens every time a rocket engine fires. It shoots out a crazy amount of gas, and that gas compresses on itself. Looks kind of like a heat shield. Yeah. That shock wave right there. You know how I always say rocket engines will do damage at close range? You get hit from that at close range, yeah, you're not going to have a good day. The overpressure event. Yeah, that'll hurt. You don't want that. I know that's the case with an ablative heat shield, but what about tile-based ones? So Smuck, tile-based ones actually absorb the heat straight up. Absorb the heat. The tiles have an insanely high critical mass. Meaning they can absorb a ton of heat before they'll start to do bad things. They're basically rocks. Basically rocks. You know, you have a little chunk of aluminum, you hit that with a blowtorch, it'll hit critical mass and it'll melt, right? It can only absorb so much heat before the aluminum will just start to change phase. If you tried to do the same thing with a rock, you're going to be sitting there for a little while. That's what those things are. The tiles are rocks. They can absorb insane amounts of heat. Just like a rock. Not the Chevy. An actual... Like the guy that invented the pet rock. The guy made $1 million. So, basically, because they can absorb so much heat, Smug, on the front of Starship, there's a lot of compressed air, and because they can absorb the heat, it just pushes it out of the way. Yeah, just like the space shuttle. The space shuttle did the same thing. The space shuttle's nose cone just basically pushed the plasma away. That's why it has such a weird shape. It has a weird shape that kind of looks like a bulbous bow on a ship, because moving plasma out and away is kind of like moving water out of the way on a hull. Same concept, believe it or not. But since plasma works a little bit differently than water, you get a little bit of a different shape. I can show you. Here, take a look. That's what we're talking about here. The tiles in the nose cone on the shuttle was the big one. The nose cone just straight up resists the heat. It's called reinforced carbon-carbon. It's like I don't know if there's like a real life equivalent. Carbon ceramic brake rotor on a car would be it's derived from that, believe it or not. And the space shuttle's nose cone is derived from the nose cone of a nuclear warhead. Yeah, that's where they got the idea. Because nukes need to straight up resist re-entry heat, or else your nuke will melt on the way down before it pops. So the nose cone basically straight up resists the heat. It can absorb heat. It can take heat at that temperature, no problem. And it pushes the plasma out of the way, similar to a bulbous bow on a ship. And now, with this hypersonic wind tunnel test, you can see the exact reason why the shuttle has dark tiles on the bottom and white tiles on the top. On the leeward side, the boundary layer where the plasma is not near the shuttle. On the bottom, though, yeah, the closer this line is to the shuttle, the more problems you're going to have. And then there's also reinforced carbon-carbon, RCC for short, on the shuttle's leading edges. The reason why is because this nose cone pushes the plasma out in a way, and it literally envelops the shuttle in a cone. The problem is because the shuttle needed such big wings for the cross-range capability that the wings go outside of that cone. They go outside of the cone. Straight up. Starship doesn't necessarily need to worry about that, but I'll get to that in a second. So that cone that's made by the nose cone, it'll change its angle depending on the speed. At higher speed, the angle of that shock wave will start basically right here. And as the shuttle slows down more and more, it'll move outwards. And that is the reason why a lot of the shuttle's leading edge has that reinforced carbon-carbon on it, because it's dealing with the wake of the bow. Only the wake is 3,000 degrees Fahrenheit and coming at you like a knife of plasma. So it starts right there. It starts basically parallel to the shuttle's hull at high speeds when the shuttle hits entry interface. And then over time, it'll move it out more and more, and that cone, the shape of the cone will get wider like an aperture almost. Very easy to believe. Hydrodynamics was exactly what I was thinking of. Nuclear reentry vehicles are more likely to use transpiration cooling. They could use transpiration or RCC. I think transpiration on the newer things, but I don't know. That's something I probably... if I knew that information, I probably wouldn't be telling you. You know what I mean? Yeah, see that? It's designed to shoot that cone out over the wing, because the wings in this thing can't push that plasma out all the way, because the thing still needs to be kind of aerodynamic. It's not very aerodynamic. It's kind of aerodynamic. If you made that nose cone the size of the entire shuttle, it could push the plasma out, but then you have something that has the aerodynamics of a steam engine. So they had to make it somewhat aerodynamic. It still flies like a brick though, but that is by design. It is designed to slow down. It's a re-entry vehicle. But yeah. Now Starship has a little bit of a different thing going on. Starship doesn't use reinforced carbon-carbon, all right? So So there's different shapes, right, for different types of reentry. I gotta find the picture. Here we go. Here's what Starship is designed to do. So remember I told you the shape that's hitting the plasma is the important one, right? That's really important. Now, the space shuttle used its nose cone to push that plasma away. Starship uses the entire hull to do that. That's why it has no RCC at the nose cone. So the space shuttle's nose cone was basically shaped kind of like a heat shield to push the shock away. If you picture a Starship like this and we're looking at a Starship from the top, right? Look at what it does with the blunt body concept. That's the exact thing that Starship is going to do right there. See what I'm talking about? Nuclear warheads use something like this over here. A capsule uses something like that. And coincidentally, the shuttle's nose cone is basically a heat shield pasted right to the front. Now, don't get me wrong, the shape isn't as uniform as like a capsule heat shield, because it's designed to shoot the plasma out and away from the shuttle in a very specific way. So once again, like this. That's why the shuttle's nose cone is shaped like this. Now Starship will do something kind of like this, but it'll be at a much higher angle of attack. Most of Starship's reentry is going to be coming in with the tiles facing right into the heat. The shuttle kind of did that, but it really relies on the nose cone to pierce the plasma and move it away. Starship is not going to do that. Starship's going to do something like this. So it's basically going to come in like this the entire time. 90 degrees angle of attack. Relative to prograde velocity. Or relative to windward velocity, I should say. So it's going to come in like this during re-entry. It's basically just going to stay like that. And then, it'll start to pitch forward when they get out of the re-entry effects, right? And then it basically stays up there, like the space shuttle, very similar. It'll stay up there to minimize overall heat temperature, but the length of heating will be longer. Okay? So it'll stay up there like this, and once again, it'll be fiery for a lot longer, but the overall temperature will be lower. Reentry kind of works like cooking food, honestly. The shuttle, Starship, the X-37, Dream Chaser, most capsules, slow cooker. Slow cooker. Low temperature, long period of heating. Okay? A reentry vehicle like a nuclear warhead, that's flash frying something. So straight down, right through, full send through the atmosphere, and you get a shorter period of heating, but you get a much higher temperature. So to keep G-forces down so you don't liquefy your crew, and to keep the temperatures, basically, to keep peak heating low, they stay up there. They stay in the upper atmosphere for a very long time. Shuttle basically stalls over its launch site and then just noses down and finds the runway. Starship's basically going to do the same thing. If this is the ground, Starship's going to come in like this, and then it's basically going to stall over the launch site and then come down and do its belly flop and then flip and land. Same idea. Dream Chaser, when that thing flies, X-37 does that. They all do that. It's like cooking, man. You want to slow cook the capsule. You don't want to flash fry it. If you flash fry it, you kill the crew instantly, and the capsule will pop like a zit. Yeah, you don't want to liquefy your crew. It's important to understand that. But the way Starship does it will be like this, not necessarily like this or like what I showed you with the shuttle re-entry. It needs to be aerodynamic enough to get into orbit in the first place. Yep. So, I mean, look at this thing. This thing creates an insane amount of drag. Look at all the turbulent airflow that's coming off of this thing. And see, there's little winglings coming off the side. Picture those to be where Starship's wings are. It's almost like this concept was figured out, well, 70 years ago almost. 68 years ago? So crew tendies equals bad. The crew can eat tendies, but you don't want the crew turning into tendies. That happened a couple of times. It's not good. It's not good. Respect. But yeah, you don't want that. But yeah, very interesting stuff, right? So poor old Cleater, toast is toast. Nah, it's all right. I care more about independence anyway. Toast is cool. Independence is cooler. The little wingling coming off the side. Yeah, that looks good coming out of the back of its neck there. The thermokinetic description of bodies when passing through a plastic medium at nonlinear density, which can at random velocities and angles, which can be just summed up by this formula here. Independence needs to stop throwing its supercharger drive belt. Buck, you want to know why I think it's doing that? If you really want my honest opinion, that thing keeps throwing belts because of thermodynamics. Your pulleys are made out of aluminum, and it's a non-intercooled design. So post-supercharger, you're getting extremely hot. I think that bracket is warping under heat load, if you really want my honest opinion, because they laser-lined it. What else could it be? I think the bracket is deforming under heat load, and that's why it throws the belts. Because it always seems to throw the belt at the same time. After like the first 15, 20 seconds. So that's my guess. I don't know. I might be just talking out of my tail. I have no idea. We're talking about a guy with a car that has a belt for his supercharger, right? To provide forced induction for the engine. And the pulleys weren't aligned the first time, so your belt pulley was over here, and belts need to go straight. They need to be completely coplanar between the pulleys, or else you'll throw the belt like a bicycle chain. It's no good. You don't want that. It keeps throwing the belt at the same time, even though the pulleys are lined up. That tells me that there's some thermo in there that's not being taken into account. What else could it be? That's my guess, Tessa, but I'm not sure. Something is deforming under heat load. It always happens at the same time. It throws the belt like 15, 20 seconds into the burnout. Something's getting too hot under there, and that's why it's deforming. But that's just my guess. I mean, if you're using an aluminum bracket, that's relatively close to the header, and post-forced induction, yeah, that's going to get extremely hot. What type of supercharger? It's a ProCharger. ProCharger, centrifugal. It's not roots. Smuck. It's a centrifugal on the side. Here, I'll show you. I'm sure Derek will figure it out, but so we're talking about this car, which is just one of the coolest looking cars on YouTube right now. That's my favorite. Oh, it's so freaking cool. That's such a cool car. Let me see if I can get a picture of the engine bay. I'm pretty sure it's a Procharger. It's Procharged, but I could be wrong. So here's a picture of the brackets here. I mean, this thing is over the header. It's sucking in warm air. Oh. Oh boy. It's sucking in all the heat from the header. Yeah, I'm gonna go ahead and say that that's probably your problem. Your Procharger's sucking in warm air, and your wastegate will literally bleed waste air right into the intake. Ooh. Yeah. Yeah, I'm gonna go ahead and guess that that's probably the issue. It's thermo, but yeah, that's an awesome car, and I know Derek will figure it out. He's a smart dude. That's from a YouTube channel called Vice Grip Garage. Basically, the guy rescued that car. He found it basically not in a junkyard, but about as close as a car could be to being in a junkyard. It looked like this when he started. And he rescued the thing and drove it 600 miles home. Like literally Route 154, only with a much crappier car. Suggested? I don't know, man. I'm sure he'll figure it out. Derek's smart enough. And yeah, he drove it back and restored it and turned it into a burnout vehicle, which is cool. I mean, I don't know, man. I ain't an expert with that, but who knows? I don't see how energy from the charge air would transfer to a mounting bracket, even if it were not enough within 15 to 20 seconds to deform a bracket enough to throw a belt that wouldn't otherwise throw. Yeah, Smuck, I don't know. It was just a guess. Why else would it throw in the first 15 or 20 seconds every time, even though they laser line the belts? What else could it be? Maybe the crankshaft pulley is eccentric. Maybe it's not mounted correctly. I don't know. It could be a ton. Maybe one of the pulleys is like this. Those pulleys have to be very smooth. There's a lot of dynamics involved there that could be throwing a belt. Like I said, my guess would have been thermo, but yeah, I don't know. I don't know if like the heating conditions. Did he let it get up to temp? If you let it get up to temp, then it could overheat it pretty quick. Something else about that setup isn't right. A weak tensioner. They replaced the tensioners between the Smuck. The first time it did the burnouts, it threw the pulley and guy didn't notice. Yeah, that didn't end well. The second time they fixed everything, put two tensioners in because there was a single one, so they put double tensioners in, one on the top, one on the bottom, two idlers, right? And it threw a belt again. And then they laser lined the belts, put it back together, and it threw the belt again. It's very weird. It's very strange. No, they replaced the belt every time, Sun Temple. Very weird. The first time it destroyed the car and the engine. High RPM crank pulley wobble, I'd bet. It's got to be something like that. The crazy part is, between the first test where it wrecked everything and the second test, it was a different engine, Mile. It's very strange. You'd think they'd get the pulley wrong 2 times in a row? Very interesting. It's throwing them. The first one it tore it to smithereens, Jason. But then it just started throwing the belts. You guys should watch the video. Go watch Derek. Here, I'll link up the video if you guys want to see it. If you guys want to look at what happened, it's pretty interesting. I mean, don't go saying, "Oh, well, EJ said this." Don't do that. Just go enjoy the damn video.
Hey, welcome back.
Here, let's see. I have it up over here. Procharger pulley bolts to the crank, different engine, same bolt-on supercharger pulley. Yeah, Mile. One of them's gotta not be balanced correctly. That's my guess. Yeah, that would probably make more sense too, more than the thermo would. But also, Yep. Nope. I like that. Yep. Nope. Yep. Nope. Yep. Nope. And that's all you guys get to see. Go watch the video. Yep. Nope. Don't hate that. That's pretty neat. Anyway, back over to space news. Yep. Yep. That's a red, white, and blue car burning a red and a blue tire. Yep. That's... I don't hate that. Anyway, check this out. We got a new tweet from Rocket Lab. Look. The next recovery booster is already lined up at the factory, this time with an added thermal protection system for a new shiny look. Oh, shiny Electron. Remember, chat, everything is chrome in the future. Is there KSP tonight? I'm not sure, Wimpy. Maybe. Yeah, that's pretty dope right there. Yeah, I don't hate that. Yeah. Also, the Mecanum wheels. That's actually pretty cool. Yeah, that's... So, this is part of a thermal protection system that Electron is getting added to it to specialize in booster reuse. Electron is recently... Rocket Lab has been trying to... Well, not trying to. They're moving towards reusing one of these things. At first they wanted to go all expendable, but then they realized that a carbon fiber booster, which is what Electron is made out of, a carbon fiber booster can survive re-entry because it's very light, especially if you employ it on a small scale. So what they're trying to do is parachute the booster down and then catch that parachute rigging with a helicopter. No propulsive landing like SpaceX. They're trying to catch it with a helicopter because it's light, and then bring the thing back to reuse again. The last mission that they flew, they did get that. They got the first stage back, but it did parachute into the water. Let's see. There should be pictures around here somewhere. Yeah, see? There it is. On the recovery ship. Can they really catch it? Sure. Yeah, wouldn't, believe it or not, that idea's been done already. People have caught stuff coming back from space with a helicopter or an airplane. Once upon a time, early spy satellites, right? They weren't digital. They took pictures, and so they had film canisters, right? And when the film canisters are out, you dump the satellite, put it in a graveyard orbit, or deorbit it and send out another one. The satellites had little tiny pods that were about this big, and when the satellite was done taking pictures, it would eject the film cartridge into this pod. The pod would close, and it would re-enter. Now, this little pod that's about this big had parachutes on it, right? You'd put the film in, and they'd have a parachute on it, and the spy satellite would assemble this thing and throw it down towards the Earth, right? It would eject it and put it on a re-entry trajectory. And then when that little pod, it would make it through re-entry because it's got a heat shield, right? It would parachute down with a drogue and then a main chute, and then a C-123, so an airplane, would fly near it, and it would have a drogue chute, kind of like a refueling arm, right? Sitting out the back to stabilize it, and they'd fly that through the parachute. The thing would hit the parachute, and it would clench the parachute, and then that's all attached to a pulley in the back of the cargo plane, and they'd just reel it in. Oh yeah, that actually happened. Yeah. Here, I'll see if we can find a picture of it. Yeah, basically a hook. Yep. Yeah, they would snag it right out of the air with one of these bad boys. Let me find a picture. If you guys like the movie Con Air, that plane. This guy. Yeah, they would just have a hook hanging out the back. You could do people too. Yep. Yeah, and then they proposed doing it with people too. Absolutely crazy. That's some James Bond stuff right there. Sure, Jack. I remember seeing a big horizontal plane Y shape on the front of an aircraft to fly directly into it. Something like that. Yeah. Like I said, there's been plenty of different examples. The C-123 is just one example, guys. Dude, they were willing to try whatever to get ahead during the Cold War. They're both sides are willing to basically throw engineering at the wall and see what sticks. Anyway, we have let's get into some Russian news here. So the Russians are getting ready to launch their Prichal module, which will launch tomorrow morning at 8 Eastern time, which is basically during the day. It's another ISS module that's going to be attached. So we got some footage of the booster being put together and integration here. Check this out. So this is a crew briefing here about assembly operations. Oh, there they go. Putting the fairing on top of the third stage right there. This big vent right here is for HVAC to keep the payload cool. Remember, payloads are designed to operate up in space. They don't operate down here very well. You have to keep that fairing cool. You don't want it to melt. That's absolutely a thing on most rockets. Yeah, Jarvis, I know about that. I was just giving one example, but there are other examples. See, that's where they pump the cold air in and then it comes out the bottom. They keep positive pressure inside of the fairing, keep it circulating. It also prevents foreign object debris. And once again, that's not just the Russians. Everybody does that. Hello. Excuse me. Привет. I don't hate what's going on here. Twins, Basil. Twins, Basil. Whoa. Shporka rocket nositel Soyuz 2-1V. And progress. Yeah. Okay. That's the special type of progress that has Prichal attached to the front. Hello. So third stage is made into payload fairing, and then it's lifted up in one assembly. So progress M. I'm not sure what the Y is. I forget what that is. It's the utility, progress utility. It's not that ironic. So that's the type of progress capsule that's launching. Soyuz 21B. So Soyuz. And then Prichal is the name of the utility module right there. It looks like the Space Corps from Portal. It's a multi-axis node that's being attached to the space station. It's going to go onto the science module, Nauka module, which was launched earlier this year. Is this in the queue? We went over that already, Hell Hydra. Thanks, Gil. Yep, there's your pilot dowel right there. They're gonna, actually that's the bolt. So it looks like they're using a frangible nut in there. Basically they use those bolts to pilot it, make sure that the flanges line up, and then they use a bolt to bolt that whole thing down. The thing is, the bolt is what's called a frangible nut. This is a frangible nut and an explosive bolt. NASA uses something similar to these. Those are the pilot dowels on the sides there, right? This will go through there. The pilot dowels will line you up to make sure that's centered. And then during separation, there's an explosive nut that it basically looks like a regular nut and it cracks in two pieces. That's why it's in this compartment right there, because you don't want that cracking, exploding, and hitting the engine that's inside of this orange piece right here. And then this thing, it pops and it falls down into this. It falls down into that chute. There's basically a huge hollow compartment in here. So the nut explodes, it stays inside of this, and then the bolt pops in half and it falls down. To get it, obviously you don't want any pieces near the rocket engine when it's firing, so they have compartments to store these things. Vitaly, the Y... It's utility node, isn't it, Vitaly? Hey, Ryo, 5-month resub. Thank you. Uzlovoy is what it's called. Is it not? I didn't see that word there, but yeah. So node module. Okay. Do these more modern Soyuz launchers use engines that require a little bit of a high test peroxide to run the turbopumps, or are they different operation cycle now? Pretty sure that hasn't changed, Synerd, but I could be wrong. Yep. Pilot dowel's right there. And you see that the pilot dowel is removable. They'll get it lined up, they'll bolt the thing, and then to save some mass, you take the pilot dowel out and you reuse it when you're integrating the next one. Yeah, what the hell happened there? Huh. Okay. Huh. I don't know what that's about. Oh, it's supposed to be like that. Alright. Just the leftover from the mechanical process. And now Soyuz does have these struts here. It's on a hollow interstage because, believe it or not, to control what's called ullage, tank ullage during staging, they fire the second stage or the third stage engine while the second stage engine is still firing. They do that to keep the vehicle under constant acceleration so they can start the second stage engines or the third stage engines and have all the propellants at the bottom of the fuel tank because the vehicle's under acceleration. That's why Soyuz has this kind of lattice system here. So the engine can fire and the exhaust goes out the sides. And, I mean, yeah, it's going to damage the core stage a little bit. Most likely it's going to burn some paint off because the engine fired, right? But you're not reusing this, so who cares? It's called hot staging. Yeah, that's why, if you ever wondered why the Soyuz just has a bunch of trusses here. Yep. All right, and now this should be footage of Pritchell getting assembled here.
В соответствии с распоряжением директора филиала выполняем транспортирование ракеты космического назначения с технической позиции на стартовый комплекс.
He said something about the final integration and then transportation to the pad, I think. That's just a guess. It's just a guess. I'm still learning.
7 часов 30 минут начало движения.
Nice train. I like trains. Man, it's already snowing in Vostochny. Nope, not Vostochny, Baikonur. Great footage, if I do say so myself. This is the Soyuz erector right here, and then the blue car is the climate control and all the HVAC systems to make sure the rocket's powered and make sure that pressure is being circulated. It's basically a big air conditioner in there, amongst other things. Let me see, on sister. Hey, very nice, very nice. That says Energia right there. Energia is the company that operates Soyuz. It's a state-owned company, but... Yep, undoing the HVAC systems. That's a big old valve. That's a big old butterfly valve. And now, I wonder if they're going to show... Yep, alright, cool. Watch this. So there are these two huge guide pins on the erector. And when it gets near the pad, the guide pins fall into place and they actually end up being a support. And then they'll plug in the PTO on this thing and then we go. Can I get a link to this? Sure. She got some big hydraulics in here. See, there's your pins right there. There's one here and one here. And they actually kind of hang it over its launch pad and turn it upright and it kind of goes into it. And see, there's the guide pins on the erector. This is to provide support because they're tilting this thing kind of over the edge here. It has these downward supports to make sure that the thing doesn't fall into the freaking pad. What does HVAC mean? Heating, venting, and air conditioning, G. It's basically air conditioning and heating. What a piece of junk. Should make 0.5 past light speed. When was the last time that Progress launched with a new module on it? Piers? Yep, this is the service gantry down here. What they're going to do is move the igniters into position here. Soyuz has the starter motors, quote unquote, for the rocket engines are actually on the pad. Because this is a one-time use. These engines only need to fire once, right? So, like a top fuel dragster wouldn't have a starter motor on it, or the SR-71, that didn't have a starter motor on it. Did it to save weight, or mass in the case of rockets, right? So, these little things that pivot, they basically shove a match up the nozzle, up each nozzle. Yeah, literally a match. Start flowing the propellants, light the match. And then, the engine turns on. Nah, the Russians don't care, Tessa. This is great footage. I'll show this all day. This is fantastic. Rip it. With a 19-month resub. Yep, these are the hold points. Soyuz, actually, its hold down points are on the second stage, believe it or not. The 4 boosters are the first stage. The core stage is the second stage. And then the upper stage, what we would call an upper stage, that's the third stage. So the second stage is what's holding this thing. That's the hold down points. And you see those gigantic counterweights. When Soyuz's engines light and they get going, right? The only thing that's really holding this thing to the pad is gravity. So once the engines get past a TWR of 1.0, the rocket slips out of its launch clamps. Just slips right out. And once it slips out of the launch clamps, these counterweights will push the hold down arms back. And then there's a huge shock absorber right here to make sure that they don't bang into the bump stop, and then like go back in and hit the rocket. There's a huge pair of shock absorbers. You can see them. They're right there. Pretty freaking cool, man. Yeah, see, they haven't moved all of them in. Now they're all conjoined. Soyuz is attached to the pad, so they can retract the erector. The erector is the green piece of equipment on the side. This is the rotating service structure here. There's 2 RSSs. They actually rotate up like this to encapsulate the rocket for final checks. Yeah, Tiggs. Korolev had this figured out in 1957. Credit where credit is due. That's damn smart. This is really, really smart. I mean, he wrote the book on how to put a rocket together. It's really, really, really cutting edge stuff. See, they're moving the erector back. They moved it back like this, and then they undid it because Soyuz is bolted to the pad, and then they'll pull the erector away, and then they'll set it back down. This is what I keep seeing flying over. It's completely white. Sorry for how bad the picture is. That looks like a KC-46, if I had to guess. Who did you say wrote the book? Korolev. Sergei Korolev is the guy that came up with all this. Sergei Korolev to Soyuz is what Elon Musk is to Starship. So, you know, no, he didn't do it by himself, but he was the chief designer, just like Elon is the chief designer at SpaceX. Most of the reason why Starship is the way that it is because of Wario over there. All right? So Korolev was the same way with Soyuz. He designed that all himself. It was his idea. He just had a bunch of people working for him. Tsiolkovsky did the math, though. Okay. I'm not sure how that's particularly pertinent, but yeah, I mean, you're not wrong. Yeah, they scrap it, Tessa, but yeah. There's the RSS moving into position, and then they stopped. Cool. Great integration footage. When is that bad boy getting shot up? 12 hours? Give or take? Actually, 13. 13 hours from now. Yeah, Night Viper, I didn't really look at it good enough to know. I mean, it could be a 777, could be a 737, could be a KC-46. How do you know all this? Self-taught-ish, yeah. Yeah, I taught myself all this stuff. I read too much. I read way too much. Yeah. Yeah, I mean, don't get me wrong. With the Russian stuff, there are viewers that are over in Russia that help me translate some of it so I can figure out what the frick's going on over there. Because I'm not very good at speaking Russian. But yeah, I'm self-taught when it comes to this stuff, guys. All the engineering, it's all self-taught. And I want to make it a thing. I want to let you know it's all off the cuff too. I don't have any cheat sheets here. I just have Streamlabs open, chat, and OBS, and then Discord is open too, but that doesn't help. I try to make sure that I'm communicating to you this stuff off the top of my head to show a grasp of understanding. You know? Hey, Capybara. It's good to see the internet people again after a 22-hour blackout. Yikes. Do astronauts that go to the ISS have to learn Russian? If they fly on Soyuz J, it would probably be a good idea. And then a lot of the Russians that go up there, a lot of the cosmonauts know English too. And a lot of astronauts just know Russian in general. But if you fly on a Soyuz, you need to know Russian. It's part of cosmonaut training. So if a NASA astronaut's flying on Soyuz, they go to the Gagarin Cosmonaut Training Center, GCTC for short, which is basically the Russians' Johnson Space Center, and learning Russian is part of that. You know what? Russian ain't too bad. It's the pronunciations that are a pain in the butt, because there's pronunciations in Russian that aren't in English. So some words are very weird. It's very weird pronunciation. It's not that bad, Pegster. It really isn't. I mean, take it from someone that's learning it. It's not too bad. The thing is that there are letters in Russian, there are letters in Cyrillic that are the same as letters in English but have a different pronunciation. That's what screws with me the most. So like a B in Cyrillic is V in English. So like Vostok or East, for instance, would be Bostok if you pronounced it in English. Yeah, it's not too bad. It's not too bad. But yeah, it's just the pronunciations that get you. Once you figure out the letters ain't too hard. Most of a lot of it's just English words with Russian. It's kind of like kanji in Japanese, where they just make up characters for words that don't exist in Japanese. It's kind of similar to that. So like automobile, for instance, in Russian is avtomobili. It's literally just automobile with Russian letters. Pamela Gay speaks Russian. I'm going to have to speak Russian with her next time I see her, Jen. I'll do it out of nowhere and she'll be like, huh? It'll be pretty cool. You have a Vostok watch. Really neat with the Russian alphabet. Yep. Cool. Anyway, we got a little bit more space news. Check this out. So this is coming from Xterra JSC. I've not seen this before, but supposedly we have the NS-19 crew for Blue Origin. You know what? I'm just going to go straight to Blue Origin proper, just to be sure. Also, word for car, machina. Yeah. Okay, here we go. We're thrilled to welcome Laura Shepard Churchley, Michael Strahan, Dylan Taylor, Evan Dick, Lane Bess, and Cameron Bess on the New Shepard NS-19 mission to space on December 9th. Strahan? Strahan! Huh. So this is your NS-19 crew. I only know who Michael Strahan is. Yep, I'll be honest with you. Because football. He's an American football player, and he hosts Good Morning America, amongst other things. American football, Tessie. He played for the Giants. Laura Shepard Churchley. Oh, crap. That's Alan Shepard's daughter. Ah. First NFL player to actually go into space. Leland Melvin was drafted, but he never played. Cool. That's pretty sweet. I don't know who the rest of these folks are. Like... And one of them is a big investor in the space industry. Okay. Here, let's take a look. This is a Blue Origin press release. Alan Shepard's daughter, Laura Shepard Churchley, and GMA co-anchor Michael Strahan. Good Morning America. It's a big morning talk show in the States. Boomers watch it. I don't know what you want. No, I'm just kidding. But not really. Strahan to fly on NS-19 alongside 4 customers. Okay. Good Morning America anchor Michael Strahan and Laura Shepard Churchley, the eldest daughter, Alan Shepard, who was the first American to fly into space. 4 customers include space industry executive and philanthropist Dylan Taylor, investor Evan Dick, Bees Ventures founder Lane Bess and Cameron Bess. Lane and Cameron will become the first parent-child pair to fly into space. Oh. I was going to say, who's the kid? Interesting. Cool. Mindless coffee banter at its finest.
Discovery,
savage. Savage. Yeah. Hedge fund. Yeah, whatever, man. It's alright. That's more money towards space. Who cares? Hey, Denny, how much are these tickets to near space on Blue Origin these days? 250 G's, if I'm remembering right. I want to read about the kid. I'm just curious here. So his dad, Lane, is the principal and founder of Best Ventures in Advisory, a family fund supporting technology firms that innovate and disrupt across multiple market sectors. Nice. Lane is best known for having helped start and build 2 of the most important cybersecurity companies in the public markets, Zscaler and Palo Alto Networks. Lane also serves as a trustee at Carnegie Mellon University and, along with his family, supports philanthropic interests across health and social sciences. Or health and social issues. Okay, cool. Why call them crew? Because Blue Origin does. Guys, I don't... Dude, we could call them bananas for all I care. I'm just reading from the article. But please, for the love of God, don't... Well, they're not astronauts. Oh, they're not crew. They're spaceflight participants. Please, 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 please. Who cares? Who cares what they're called? I don't care. It doesn't bother me. So this is the hot dog... Is a hot dog a sandwich argument? It's needless compartmentalization. Who cares? Space bananas. Okay, Cameron is a content creator with a passion for creating and expressing themselves in a way that can brighten a person's day. After studying computer science and game design at DigiPen Institute for Technology in Washington, they developed an engaged community across multiple platforms, producing original content and developing proprietary software to support their audience. Cameron identifies as pansexual and is proud to represent marginalized communities and hopes that their journey can inspire others. Oh, neat. All right. Cameron's on Twitch. Cool. I wonder if he knows who we are. Maybe. He's a VR tuber. Cool. I didn't know that. Neat. Hey, sweet. I'm all for people on Twitch getting launched into space. I don't know why would I do? I don't know. No ulterior motives there. What if he gets you on the next flight? Yeah, I'd do it. They're the tacos. Totally awesome crew for outer space. Well, I prefer bananas, but... What's that? Ridiculous. Oh, boy. My first attempt at modeling Raptor. Oh, you're getting there. That looks pretty good.
Discovery.
Hey, Donnie, gifted a sub to Chow Music. Thank you. Yeah, Grog, I don't care. Like I said, I don't care what they're called. I don't care who launches into space. More people launching into space is not a bad thing. Hey, Jim. 77 months. Thanks, buddy. That's cool. Grug, it's funny because that, you know, people bring up the same thing. Oh, NASA's spending too much money on things. They're spending too much money. It's too expensive. Oh, I'm sorry. I didn't realize that you thought that less money for NASA is better for spaceflight. That's cute. Huh. Interesting concept. Anyway, that's cool. Let's see. What else do we got here? Hey, Predominant, it's your birthday. Happy birthday. Bothers me that they call them astronauts. I feel like it steps on them that came to them. I'm sorry you feel that way, Lols. I don't really care. It doesn't really bother me. Like I said, we could call them banana knots for all I care. I mean, I understand where you're coming from. But, so A, they ain't gonna change it. So B, it's a problem that's out of your control, so why even let it bother you? Yeah, I get it. But once again, whether we should call them astronaut argument is that's the same as is a hot dog a sandwich. I don't care. I don't care. I just eat the hot dog. Okay? Just eat it. I don't care. I don't give a frick what it is. All right? Just launch it. Just launch it. Just put the people up there. I don't care who it is. I don't care who it is. I don't care what you want to call them. Just put the people up there. Just take the. Why don't we just take the people and put them up there? Torture him for his birthday. Sing happy birthday to him. To Predominant? Nah, I'm good. Leonauts. Sure. We could. Stark. That's fine. We call him that. Self-loading freight. I'll take it. That's fine with me. That's fine with me. We can call it that. That's fine. They launch on New Shepard, so can we just call them sheeple? I mean... yeah, that's fine. Meat bags. Well played. Yeah, Signerd, I guess. If people want to argue about nothing, that's fine. Here's another picture of the another picture of shiny electron. Here, take a look. Call them meat popsicles. Yeah. Oh, one of my lights just went out. It's dark in here. I gotta fix that. I just kicked the cord out. I'll be right back. I'm going in. I'm alive. Where's Mr. Hat? What's with shiny electron? Better thermal protection system for reuse, Okie. Yeah, that's the one they're gonna catch. I don't hate it. Now let's listen to our expert, Chair. Rocket's going to launch. Thanks, Chair. Thanks, Ali. What kind of insulation are they using for shiny electron? Tin foil? Yeah, that kind. the type of foil. I don't know, dude. I have really... And now back to you. Thanks, Chair. It's an aerogel composite. How does KSP model drag? Drag is modeled on a per part basis. Is it sacrificial? Will it need to be reapplied every flight? 2, 4, 9er, 5, 6, 7, 8. I don't know, fellas. I have no idea. I saw the shiny film on Electron for the first time a couple hours ago. Actually 7 hours ago. So yeah, I'm not 100% sure. I'll look into it because people seem to be curious. So last but not least here is NASA's DART mission launching out of Vandenberg tonight in about well, I had to count on my fingers, I'm not going to lie to you. In about 5 hours, give or take. We're just inside of 5 hours here. DART is the Double Asteroid Redirect mission. It is a satellite that a Falcon 9 is going to launch out of Vandenberg, and that satellite is going to fly out on a Hohmann transfer and collide with an asteroid called Didymos. The idea is that we're basically seeing if we can hurl satellites at asteroids to redirect them so they don't hit things. That's the idea. Double Asteroid Redirect is really cool. Really, really cool mission. Here's a picture of the satellite inside of the Falcon 9 fairing. It's very small. Usually when, you have Falcon 9, you need all this extra payload space, but it's a little tiny boy. Usually when you have something like this, it means that the payload needs to be accelerated at a very high speed. DART supposedly is going to hit Didymos going 16,000 miles an hour tangent velocity. So that's like, I don't know, 6 or 7 times faster than a bullet. Yeah, maybe, well, that's a little faster. A little faster. A thread from Peter Beck on it all. Oh, neat. Peter Beck. Peter Beck. Alright, so a little bit more on Rocket Lab here. So how far away is the asteroid? It's Didymos. So Didymos asteroid. 65803 Didymos, okay, is a sub-kilometer asteroid in a synchronous binary system classified as a potentially hazardous asteroid and a near-Earth object of both the Apollo and Amur group. The asteroid was discovered in 1996 by the Space Watch survey at Kitt Peak. It's a small 160-meter wide minor planet moon. And its 160-meter wide minor planet moon was discovered in 2003, named Dimorphos. Due to its binary nature, it was then named Didymos, the Greek word for twin. Didymos' moon, Dimorphos, is the target. Oh, it's the moon. Is the target of the DART mission to test the viability of the asteroid impact avoidance by collision with a spacecraft. While the whole system is to be visited by the Lycia Cube, a flyby CubeSat to witness DART's impact. Oh, cool. Even better. All right, where is this thing? So it's perihelion. Perihelion around the sun is 1.01 AU. That's probably why they're targeting it. The lowest point in this thing's orbit basically crosses Earth's orbit. 1 AU is Earth's semi-major axis around the sun. So that's 1 AU. That's the distance from the center of the Earth to the center of the sun. Okay? This is perihelion. Its lowest point in an orbit around the sun. Helios, right? Periapsis. So periapsis, helion, perihelion. Lowest point in solar orbit is 1.0133 AU. Its aphelion is actually out past Mars, 2.2760 AU. That's a very eccentric orbit. Ooh, DART's mission trajectory. Very nice, eh? Oh, I see what's going on in here. So sorry to interrupt. So DART's trajectory, that's the asteroid. That's the sun. Okay. So Earth's right there. Yeah, see? See the asteroid's lowest point matches up with Earth. See that? That's the perihelion right there. Apohelion's
Discovery,
way out
going
here.
throttle up.
So DART's basically going to launch. Oh, that's going to take a year to get out there. Easily. Yeah, easily going to take a year. And they're going to put it on a Hohmann transfer that's going to intersect Dimorphos's perihelion, or Didymos's perihelion. And it's going to impact right when Earth's next near it to see if they can get it to push away. Because, okay, so the reason why this is dangerous right here, all right, is because, once again, you have Dimorphos, which is orbiting around this thing. It's orbiting around it. Okay? That's no good. If it gets close enough to Earth at the same time, Earth could pull Dimorphos away from Didymos and pull it towards Earth. And yeah, that's Armageddon. That's the Armageddon scenario. That you don't want that. And it's dangerous because the perihelion is very similar to Earth. So at some point we're going to cross trajectory. Well, not at some point. My guess is sometime in 2022, in late 2022, we're going to cross paths. And they're going to see if they can boop Dimorphos away. So Earth, if this asteroid ever crosses into Earth's SOI, so basically when Earth is at its perihelion and when this thing is at its perihelion, it doesn't pull that asteroid towards Earth and cause an impact. Yeah, that would be bad. That would be bad. The NASA host said today in about 100 years it would potentially cross Earth's path. Well, there you go. What color is what on this? Bottom of the screen. But no, not nuke it. It's basically a Space Patriot missile. Just hit it. Just hit the thing. Just that. Sometimes when I get mad, I just hit the pillow. Just hit the pillow. See how you feel. How many missions has Falcon 9 launched outside of Earth's SOI so far? Transiting exoplanet survey satellite. So there's TESS. They're going to launch Psyche. They haven't launched that yet. There's the Roadster, obviously. There's your frickin' pillow. Scott has a pretty good video on this. We're also using a CubeSat to video the impact event. Yeah, that's what I was reading just a second ago. There's a European mission in planning to visit the asteroids to do a thorough survey of the effects. Cool. Cleaned my grill smoker up. Now it smells like an orange. Yep. Make sure, Ponzister, the next time you light that thing up, you give it a second to burn off all that cleaning solution, that any residue. Give it a second. It'll burn it all off, and then you cook, or else you're gonna end up eating some grill cleaner, which probably not a good idea. So these Facebook posts concerned about the butterfly effect, Facebook posts concerned about the butterfly effect actually have some merit in this case. Would you be okay with testing a nuke in the outer solar system where Earth would not get affected by the tests? Yeah, sure, why not? It's gonna bonk Dimorphos, not Didymos. Dimorphos is and I didn't know about this until I read it, I'm not gonna lie to you. Dimorphos is a small asteroid satellite. It's a 160-meter minor planet moon of Dimorphos. Let's see. How big is this sucker? So it's orbiting around it. Interesting. There you go. Yeah, it's orbiting around a big frigging asteroid. Orion drive-powered asteroid redirect when? Something asteroid space debris something. How big is the big guy? 800 kilometers with 160 kilometer, or 800 meters with 160 meter satellite around it. Yeah, there are asteroids out there with enough gravitational pull to have moons. Yeah, it's really interesting stuff. Minor planet moon. Oh, that's freaking rad, dude. Look at that. Bro, oh, that's cool. Yeah, see? Little minor planet moons orbiting around a spinning asteroid. Earth looked like that at one time. Straight up. Little bit bigger though, but kind of like that. That's really neat. The Michael Sheets Peterbeck info thread has some great info. Electron's first stage is just a tad under 1 metric ton at 990 kilograms after it returns to the atmosphere. Damn, that's light. Yeah, guys, look, NASA wouldn't try to pop an asteroid if they knew it was a direct threat. We don't know what the repercussions of that. So we targeted an asteroid that kind of could threaten Earth sometime in the future. But they're, once again, if this satellite, if DART hitting Dimorphos breaks it into pieces, that debris shower is not going to, the debris shower is either A, going to be small enough to get eaten up by Earth's atmosphere, if it does ever find Earth in 100 years or whatever, and B, it's not really that big of a threat. They're just trying to see if they can bonk it out of its orbit. If they bonk it out of its orbit, it's not really going to change much, to be honest. We'd prefer it to be broken into tiny pieces. I mean, yeah, tiny pieces would be the end, would be the hopeful result, but you ain't gonna know until you try, are you, Bob? Yeah, I mean, it's Newton's third law here. Every action has an equal and opposite reaction. The amount of force imparted from the satellite hitting the asteroid is going to be the same as the asteroid hitting the satellite. So a satellite, a very small satellite, very low mass, hitting a gigantic 160 meter wide asteroid, right? Yeah, it's not going to move the asteroid very much. It'd be like a fly buzzing around a human at best. But it's enough to, it might be enough to move it. NASA's trying to see how much it moves it. I mean, you could knock it out of the asteroids of Dimorphos' orbit. You could. I highly doubt that that's going to happen. Let me read about its orbital parameters. Hold on.
Discovery, go at throttle up.
The orbital period is about 0.01 hour. Semi-major axis is 119.3. Eccentricity is 0.5, so it's almost in a perfect circular orbit. That's very unlikely to knock that out of its orbit. It's very unlikely. That's not going to happen. No. Your eccentricity is less than 0.5 or is that greater? It's greater than 0.05. 0.05 eccentricity is not much. It should be that's relatively circular. The orbital period is 0.49 or 11. Yeah. Eccentricity of 0 is circular, Skyseas. Yeah, if it's no greater than 0.05, we're not knocking that thing out of its orbit. No way. Nah, we're not knocking that thing out of its orbit. It's circularized. It's circularized with an eccentricity lower than 0.5. So what does that mean? What does that mean in plain English? So, okay. We'll talk about orbital eccentricity, right? Orbital eccentricity, or ECC for short. Okay? So, orbital eccentricity can basically exist between 0 and 1. All right? Now, keep in mind, this is very basic stuff, all right? There's a little more complexity to it, but it basically exists between 0 and 1. If you have an orbital eccentricity, so that's not an E, ECC is equal to 0, that means your orbit is a perfect circle around whatever you're orbiting, okay? Now, over here, If your eccentricity equals 1, that means you're on an escape orbit. That's escape velocity. Any eccentricity that's beyond 1 is escape velocity. Now, anything in between, right? So let's just say escape velocity. I don't know why the second E is capitalized. Just bear with me. Now, if you have, I probably should have done this first, but if you have eccentricity that's equal to 0.5, that means you're halfway to escape velocity. So your orbit is something like that. It's an eccentric orbit that's an elliptical shape that's halfway between 0 and 1. You're halfway to escape velocity. So, what does that mean? If the eccentricity on dimorphos is closer to 0, right? If it's closer to 0, that means it's circularized, okay? Now, it's not the distance between its orbit and Didymos is not very far. It's not a long way. Now, don't get me wrong, that asteroid, that 800 meter wide asteroid doesn't have a lot of gravitational pull, and it's not going to take much to pop dimorphos out of its orbit. It's not going to take much. However, I'm pretty dang sure that DART, even if it's hitting it at a very high rate of speed, DART cannot impart enough delta V onto that asteroid to get it to break its orbit if the eccentricity is close to 0. The only way it could do that is if the orbit was circularized at a very, very high altitude relative to the gravitational pull of the asteroid. So planets have gravitational pull. You get near it, you fall into the grav well. Okay? If the asteroid is at the very edge of that grav well and circularized out there, it might not take much to push it away. It's only going to take a little bit to hit it. Now, it also kind of depends on the injection angle for Didymos. It depends. Are you hitting it when it's coming around and hitting it like here, or is the asteroid pivoting around and hitting it that way? Are you pushing it away from the asteroid, or are you hitting it when it's coming around? There's a bunch of things that you have to take into consideration there. If you hit it when it's coming around, it's going to slow down the asteroid, and that will increase its eccentricity, but it'll increase the eccentricity so it'll get closer. So Dimorphos will get closer to Didymos, and its orbit will be elliptical, but it'll be elliptical in a way that's going to actually get the thing closer to the asteroid that it's orbiting around. If you hit it with an ejection angle of the asteroid going like away, so I gotta draw it. Hold on. So if this is Didymos, right? And then this is Dimorphos, right? DM, right? And it's going like this, right? And it's orbiting that way. If DART hits it over here when it's coming around, that's going to actually slow it down. That's going to slow it down, and it will move the orbit, which is near a perfect circle, will actually end up looking like this. It'll slow it down. So that'll actually get the asteroid to get closer, right? Now, if you hit it when the asteroid is over here, right? And they kind of hit it up the rear end, that's going to increase the eccentricity this way. And that could get it to escape. My guess is, because NASA's really trying to figure out what the hell's going on, my guess is that they're going to hit it like this. So if anything, it's going to slow down and it will get closer. Dimorphos will get closer to Didymos. I'm guessing they're going to have an injection angle that hits it when it's coming around like this. If this is, this is the orbital path that it takes in its orbit around the sun, right? So the sun would be down here. I'm guessing DART is going to come in on a trajectory like this. It'll hit it head on. So head on is basically that. Yeah. You don't want to hit it when it's going away. Hitting it when it's going away like this will impart velocity on Dimorphos. Even if it's a little bit, it could be enough for it to break eccentricity. But if you hit it over here, you are increasing eccentricity, but you're increasing eccentricity in the wrong direction. That'll get it closer, not further. So yeah, the odds of this thing breaking Dimorphos breaking Didymos' orbit is very low. If NASA hits it like the top. In fact, it's probably low no matter how they hit it. It's just too big. DART is nothing. It weighs nothing. Look at it. It's a little tiny boy. It's a little tiny satellite. There's no way that's going to hit a 160 meter wide asteroid and impart anything above like maybe a maybe a centimeter a second at best, which is no, a centimeter a second at best is not enough to break that thing, break an asteroid with 800 kilometer size, or not kilometer, 800 meters. Nah, it's too small. You'd need to hit it with something the same size. Bug on a windshield, quite literally, freaky. Yeah. The pic that was linked in chat is the intercept trajectory. All right, let's see. Let's see. What's... Yep. Just as predicted. Yep. So the original orbit is circularized around Didymos. Hitting it on the retrograde vector is going to do the equivalent of a retrograde burn. DART should hit it when it's coming around, like I said, and that will lower its periapsis relative to Didymos. It'll actually make it go closer. Yeah, see, like I said, that was my guess. That's right. That's going to make it so the asteroid doesn't, it won't move. It won't leave Didymos. So the persistent threat is still kind of there, but NASA targeted this specifically because of this. That's why they did this. I'm willing to bet. They're going to hit it like this. You hit it like this? Sorry. No, they're going to hit it like this so it stays in Didymos' orbit. So basically you can redirect it and you can see if it changed its orbital parameters, and they're going to check that with Elysia CubeSat. You're going to see if it changed its eccentricity. But it's going to change its eccentricity with its orbit closer to Didymos. So that means it's less likely to break its orbit. This is the survey satellite. It's basically got a camera on DART. It's gonna film the impact. Scott claims a 0.5 millimeters per second speed change in the moon orbital velocity. I believe Scott. That sounds about right. It's nothing. Yeah, we wouldn't need to worry. Like I said, NASA's picking an asteroid that's relatively safe, but it could threaten Earth sometime. But yeah, it's going to stay around. Dimorphos is going to stay around Didymos. It's not going to mess with it too much. Well, we don't know that. We're going to see how much it's going to mess with it when it hits it, if it does. It's a difference that's going to be big enough to measure, and that's about it. Yep, they just want to see how much. Maybe we can sometime. Looking at the orbital track, Papa Bear, this mission is going to... this mission ain't going to get out there for a little while. But yeah, it's cool. I enjoyed reading about that. See my last as well. I don't want it, Jim. No, what's up? They can tell within a few observations if it changes. Well, if you hit a lone asteroid, it would take years of observations to know if it had an effect. Indeed. Yeah, makes sense. NASA doing smart things when it comes to orbital mechanics? No. Whoa. Calm down. Calm it down, bro. No, that's a good idea. It's a good way to measure it. Yeah, because if you just hit an asteroid orbiting around the sun, you'd have to wait to observe its perihelion. Screw that. And even the observations around the perihelion would be extremely hard to spot, especially from Earth. NASA's smart? Yeah, well, Panda Man, I tell you, the proof is in the pudding. Alright? What I mean by that is that NASA has the best pudding out of any federal agency 6 times running now. Stop? Nope, I'm never going to stop making the pudding joke because I think it is very funny. What's in the pudding? It's tapioca. It's great. It's rice pudding? No. The most accurate measurement about the ephemeris data of an object in solar orbit is the orbital period, correct? I think you could figure out the orbital period by how quickly it transits across the night sky. You can use some math there and see how fast it moves across the telescope. That way you can get a speed, you can get an orbital velocity, right? Or solar velocity, I guess. And then you can extrapolate the rest of the orbital data from there. We need a pudding emote like now. Seems like it's going to be September or early October when they predict the impact. It's going to take about a year, Tink. Yeah, it's going to take about a year. I don't even need to see the press kit. Looking at the orbital track from the wiki page. Looking at this right here. Yeah, that's going to take about a year. Because, okay, really easy way to tell. What's 1 year? 1 year is one revolution of the Earth. So it's launching here, right? And then the DART mission concludes over here. Almost one revolution. It's going to take about 9-10 months. So sometime next year, sometime late next year, right? Pretty easy, pretty standard stuff. It's not that hard to extrapolate that, right? Yeah, I tell you right now, that's about 1/12 of a pie slice of the orbit, right? The proof is in the pudding, man. Yeah, so sometime late next year. Yeah, that's what we're talking about here. So the blue is Earth, that's DART, that's Didymos, and these are two other asteroids that are just kind of chilling. My boy's wicked smart. Do you like apples, chat? I got an asteroid. How do you like them apples? Sure, Synerd. You want this hat? Go to Kennedy Space Center and you can get it. It's a pretty dope hat. I like it. Now, the real question, Procyon, is if you also want pudding. You want pudding as well? He's fairly brainy. Thank you, Durf. Appreciate that. Big brain. My brain has many wrinkles. I'll have you know. Many wrinkles. Did you touch the moon rocket KSC? I think that was the most fun. Yes, I have. Seeing the Saturn V really made me happy, Bob. Please? Yeah, I tell you, want pudding. Yeah. Can I get pudding in my hat? Ah, you deciphered my name. What do you want from me? All right, let's check out this thread from Rocket Lab. So this is coming from Mike Sheets, who covered the press conference about that shiny electron. The point of this flight was to test a few different technologies, but we also introduced helicopters for the first time. That's the Love at First Insight flight that we watched launch the other day. The next recovery flight will be the one where we catch the electron booster with a helicopter. Usually we see a fair bit of beating up on the heat shield on the bottom and a fair bit of load on that, but this time with the modifications we made down there for this flight, we'll be very happy with the results, hopefully. This last launch was a block upgrade for Electron, which had a lot of new changes, including a stretched second stage. Hey, Ghost One, what's up? Beck says that the next recovery attempt will be dependent on helicopter readiness, as Rocket Lab has a significantly larger helicopter in the works, and it needs some modifications done to be ready to catch Electron. I wonder what they're cooking up. Beck adds that Rocket Lab hopes to make the first helicopter catch of an Electron booster on a flight within the first half of next year, or as soon as practically possible. Okay. The Electron block upgrade is the last major upgrade to the vehicle that we were planning. No advertised increase in payload capacity due to the added it's getting too dusty in here. Due to the added hardware for recoveries. Beck said that the schedule for launching from NASA Wallops in Virginia is still a little bit up in the air, but the company will try and get there in the first half of 2022. Okay, so late 2022. Got it. The automatic flight termination system? The automatic flight termination system is the holdup. Yeah, those AFTS sisters, it's a pain in the butt. Is the holdup, which was supposed to be complete by the end of this year. Okay, yep. Aerospace timelines. What do you want? What do they mean catch? The booster's going to parachute down with like a parafoil, and it's going to be kind of going like this, and a helicopter will literally come and snag the parachute, and they'll basically wrangle the booster with a helicopter. Yeah, it's pretty rad. Yeah, it's pretty freaking cool. Here, I'll show you a video. Hold on. Here. This was a test, right? They were just testing, but this is the idea. This is with a mass simulator, dudes. This is not the real thing. Watch.
Approaching target drop location.
Watch this.
And all traffic drop test commencing in 30 seconds.
So watch. So they got a booster with the actual parachutes installed on a mass simulator. That's just basically something to test the mass. Watch this thing with the little flag on it. Watch.
Delta releasing in 5, 4, 3, 2, 1. Release.
Watch this.
Romeo in position behind test article. Initiating final catch approach.
Click. Watch this. The second they capture it, it pulls up and it compacts the chute.
And test article secured. Romeo returning to LV.
Pretty hardcore, dude. That's pretty freaking cool, man. They're gonna do this with one coming back from space next launch. I'm unfamiliar with Rocket Lab. Can I get a quick rundown on them? Well, I showed you this video for that exact reason. Rocket Lab is a small satellite, well, future, rewind 15 seconds. Rocket Lab is a small sat launch services provider. So they're a commercial launch services provider that's really kind of specializing in small satellites. They have an Electron rocket. Their Electron rocket is a carbon fiber rocket with electric fuel pumps on the engine. They got electric pumps on the motors, the Rutherford engines. Rocket Lab is basically trying to pioneer small satellite launching. The idea is that if you have a rocket that's easy to manufacture, you can manufacture a lot of them and launch them a lot. If you can launch them a lot, right, like once a week, for instance, you can basically equal out to a big rocket launching, once every couple of months. That's the idea. That was their original mission statement. Rocket Lab has kind of went away from that a little bit over the years. They originally were not going to pursue reusability, and then they decided that they were going to pursue reusability, and then something changed. Rocket Lab basically did an IPO, right? And when they did that, they greatly expanded. Peter Beck, the CEO, that's this guy over here with the curly hair. He basically greatly expanded the scope of the company. Rocket Lab is looking to make a follow-on rocket now called Neutron, which is somewhere in competition with, between Vega and Antares. And Neutron is supposedly going to be human-rated, which is... pretty neat. So, yeah, they're a cool little company. They're one of the only other operating commercial providers that are out there. I mean, they're SpaceX, obviously. there's ULA, there's Astra nowadays. Astra's made it into space. Firefly is going to very soon. ABL will as well, but they're one of the few commercial providers that are already moving stuff into space. Blue Origin has not moved any payloads into orbit, Flykin, but I guess you can count them if you want to. Was that a full weight mass simulator or just a proof of concept? That was a full weight one. The first stage weighs about 2,200 pounds, give or take. So about 1 ton. They launch out of New Zealand, Procyon? They launch out of the Mahi Peninsula in New Zealand. They are an American company, but the guy that runs it is from New Zealand, and they launch out of New Zealand. The company is based in the United States, though, because of security reasons, to say the least. Oh, I made it into space. Oh, I misheard you. Okay. I agree, Bob. The more, like I said, it's what I always say, dude. The more rockets, the better. I don't care if it's SLS. I don't care if it's Electron, Falcon 9, Starship, whatever. More rockets. ABL, Astra, Firefly, Launcher, even Spin Launch in some weird way. I'll take more rockets. Thank you very much. The more rockets, more people pursuing satellite launching capabilities, and just, frankly, orbital launch capabilities are... yeah, that's going to make for a more healthy and diverse low Earth orbit economy, and that no one can convince me that that's, that less rockets is going to be better in the long run. That's not true. And you know what? It doesn't even matter if they're reusable right now. In the future, probably, hopefully, we can move to that kind of sustainability. But yeah, there's also relativity, freaking relativity with what they're doing. I mean, it's really good time to be a space fan. Really good time. Thoughts on spin launch? Little unorthodox, but the proof of concept shows that it could work. Yeah, a little unorthodox to say the least. Has Firefly launched again since the last one? No, they haven't launched yet, Jay, but they have static fired their next booster, so their next launch will be very soon, actually. Yeah, if you go on their Twitter and look, they've static fired the next booster. Yeah, they're getting close. So, who out of all the commercial providers, who can make it into space? ULA can make it into space. SpaceX can, well, orbit. ULA can make it into orbit. SpaceX can make it into orbit. Astra can make it into orbit, which is cool. Rocket Lab makes it into orbit. And I think that's it right now. Anything I'm forgetting? Did Firefly ever figure out what specifically caused that engine to not work right? They figured it out, Signer. They wouldn't be static firing their next booster if they didn't. Northrop Grumman, yeah, if you want to include that, Northrop Grumman, sure. How long will it take DART to reach its target approximately? 11 months. Virgin Orbit, that's true. They launched one into space. Yeah, pretty cool. Watch Everyday Astronaut's video about it. It talks about the failure. I don't need to. Singularity. I have my suspicions about why that motor failed. But yeah, suspicions. But either way, it made it off the pad. That's good for a first attempt, dude. Better than most. Even NASA's early rockets. Well, I mean, those blew up on the pad. So if you can make it off the pad on the first try, that's good. Astra made it off the pad on their, 6th try. Well, that was technically the third launch, the third orbital attempt. They've made it off the pad every time, just sometimes in other directions than up. It's for the guy in chat. I got you, Singularity. Yeah. Did you see that Bill Nelson invited Bruce Willis to this launch and he turned it down? He turned it down? That's awesome. What a legend. I don't know why that's funny. You want to come down and try the pudding? No, shoot, Bill. Does it sound like I wanted a pizza? I don't know why that's funny. Does drifting count as getting off the pad? Is it still on the pad, Tessa? It ain't on the pad. I want you to come down here and check out my tapioca pudding. I got a mean recipe for it, I tell you. No, I'm good, thank you. Multi-pad drifted. Nani? Yamate. Clearing the GSE is what counts. Space Y, indeed. Tapioca is disgusting. Yeah, I think you're wrong, and I tell you, NASA would disagree with you because the proof is in the Apollo 8 pudding. What I'm trying to tell you is, you remember Apollo 8? During Apollo 8, the astronauts had pudding. Therefore, the proof was actually in the pudding. What are they going to do with an astrostage that's in orbit? Nothing. The test was to get into orbit, T-Man. Was Bruce Willis in Deep Impact or Armageddon? I'm not answering that. I've been out for a minute. What is up with Nelson and pudding? Hippo, during the Crew 3 launch, they interviewed him, and he wouldn't stop saying the proof is in the pudding. He wouldn't stop saying that. It has nothing to do with the technical infeasibility, Benno, but he wouldn't stop saying it. They're like, oh, we have Administrator Nelson here. Administrator Nelson, what are your thoughts on the Crew 3 launch? Well, we're doing a real good thing down here, and I'll tell you, the proof is in the pudding. If you go look at that launch pad, the proof is in the pudding. NASA was voted the best place to work amongst the federal government, and I'll tell you, the proof is in the pudding. He wouldn't stop saying it. He said it like 6 times. So now whenever we talk about him, we can't stop talking about pudding. Stop saying pudding! Stop that! Stop that immediately! Does the ISS have brownies or cake? I'm not sure. Yeah. Oh, I know. I did not vote to eat the vanilla pudding. I had tapioca. Excuse me, what pudding? Yeah. Glidrub, moving Artemis back. I'm sure he didn't gain any fans, that's for sure. But anyway. Your voice is just like the NFL lip reading videos. I brought you a potion and it's gonna work, and I brought you guys some potions as well, okay? I'll have your money, man. You better. I mean, you could buy a pregnant cow. I found Fido. Hey, guys, I found Fido. What's wrong with him? Sparks, it's so funny that you know that. Dude, I still, when people ask me questions, dude, sometimes they go, egg roll. I think there's a breeze coming up my leg. Zip zap, with a bop. Egg roll. People go, what? I'm like, nothing. Egg roll. Skipped up double flavored Scooby snack. Okay, are we done? Are we done here? What are we doing? Oh, man. Sorry, that's really funny. Egg roll. That's funny that you mentioned that, man. Those things used to make me laugh so much. Oh, dear. Okay. Satisfactory? Oh, man, that update 5 is really wants me to want to play it, but we also got to play some KSP. But also, so Hearts of Iron? No. We already played Hearts of Iron today. Nothing wrong with a good laugh before Thanksgiving. You know what? I've decided. I'm bringing pudding. I'm bringing a big bowl of pudding to Thanksgiving dinner. And I'm going to go around and I'm going to do this voice the entire time. My family will get very confused. And every time they ask me, why are you talking like Bill Clinton? I'll be like, no, wrong Bill. I'm going to say, well, the proof is in the pudding. And no one's going to get the joke. And it's going to be really, it'll be funny to me. Like, that sounds hilarious. Like, wrong Bill? I'd be like, no, different Bill. What pudding did you bring? Well, I tell you, I brought the best pudding, and the proof is in it. That's never not going to be funny to me. Bree might get it? Yeah. Yeah. Wouldn't mind seeing more space shenanigans. Yeah, okay. At least 90 to 154 proof of the pudding. Bring 30% proof pudding. Are you guys saying bring Jello shots or? Print out proof on paper and put it in the pudding? That's so stupid, Ian. I love it. It's so dumb. I'll tell you, the proof is in. Oh my god. Why is that funny? Why is that so damn funny? It's so screwed up. I don't like harping on Bill all the time, but also. Okay. So, we got the DART launch. DART is in 5 hours, give or take. I'll start coverage when NASA starts coverage, which should be a good ways out. So we got supersonic retro pudding. Oh my god. On one hand, we got pudding, and on the other one, we have KSP. Jim, it's so stupid. It's so dumb. I'm starting to think I just like saying pudding. Kerbal Space Pudding. That's right. I'd kill for a cookie. Stingray, a double-sided Scooby snack, egg roll. I'm telling you, I do that. Brimo will ask me a question, I'll be like, egg roll. Like, what? It's funny to me, though. Oh, man. Well, we only got a few hours to the launch, so status for the funsies and all KSP tomorrow. Full flow stage pudding cycle. Stop it. Stop that. You stop this now. My favorite Roadhouse. Who could easily get a Freedom launch in. Are you staying up for the next 5 hours? Absolutely, Procyon. I cover all launches on here, at least as much as I possibly can before I keel over and fall asleep. What is this? Don't do that again. Don't do that again. Don't do that again. And Ian, for what it's worth, I agree with your Twitter post. No commercial. I shouldn't ask my doctor about blah, 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 blah. Yep, you're absolutely right. I thought it was funny. Thank you, sir. Yep. It's all that, dude. It like watching a football game. It's like when they go to commercial break, mute. Mute. There is one drug though. There is one drug that, you know, I'm okay with the commercial. Here, I'll show you. Here, check it out. I'm not paid to say this. Don't worry. I'm not paid. This is just EJ thinks this is funny. Okay? Check it out. Oh, it cured your anxiety? Oh, you have that too? Oh, it's wonder drug, really. Really. Really is. Yep.
Discovery.
Hey, Ratsky, 26-month resub. Oh, boy. All right. You know what I'm going to try to do? I'm going to try to get one commercial launch off with Freedom in Kerbal. And then after that, if there's time, we'll play Satisfactory. Let's get the Kerbal done now. We need to build up that money so we can get freaking stupid SSTOs working again. Because, yeah, I screwed the pooch on that one pretty badly. You know, that's good. It's fine. Just exploded and cost me $1 million. Whatever. It's fine. I'll have pudding instead. Asteroid redirect mission. We can't... I don't have any asteroid detection. What did I miss with the SSTO? It blew up on the pad because of the docking module fix mod that I installed. Yeah, totally my fault. Install the mod, thing exploded on the pad because, you know, who knew? Changing the docking behaviors made the pad work differently. What was the name of that drug again that I just showed? An asteroid redirect mission. You're joking. All right. Copium. No, not that one. No, I don't like that drug. That was a bad one. So when are we getting KSP2? Oh, when it